Cool. So, all right, let me officially open things up today. So after countless reminders and other pestering emails, I'm pleased to officially welcome you all to our TinyML workshop today. So we have friends on the line from Edge Impulse. I believe we're going to have some people from Datacake as well. They're not here yet, but I think they'll be here shortly. So we're super happy to have you all here. And there are really a lot of you again. We did run this same workshop or a very similar one about 4 months ago. It went really well. Consider this like a 1.1 release. I think we've smoothed out some of the edges. And so it should be a really great experience here. Speaking of, if I can advance, there we go. I want to set some expectations for today, specifically around the scope of what we're going to cover and how we're going to cover it. So let's start with this This is very much a hands-on workshop, hands-on AIoT workshop. So what is AIoT? Well, it stands for Artificial Intelligence of Things and really represents this awesome combination of machine learning, IoT, and the cloud. So the vast majority of our time spent together today is literally going to be hands-on. To that end, expect the content to be very functional in nature. This is more of a how-to than an explanation of the theory or the background of these technologies. So I like to think of this as a really comprehensive getting started tutorial, if you will, that covers cellular IoT, cloud dashboards with like IoT platform, and machine learning on tiny devices. Likewise, what this is not, don't consider this a deep dive into AI or ML. As mentioned, this is a very pragmatic, functional look at these technologies. It's also not necessarily a forum for specific use cases. If you have specific questions, of course, we are here to answer those questions as they come up, but don't expect us to take a half hour to dive into a very specific use case. We're trying to make this really trim. We're going to run a really tight ship and try and get through everything as quickly as possible. But there is a lot to cover in our extensive agenda. So let's kind of dive into what you can expect there, as well as do some intros. So first is me. I'm the least important person here. I am Director of Developer Relations at Blues. I'm going to kick things off, or I'm kicking things off right now, and I'll be providing a quick overview of the agenda, what we're going to cover. Well, actually, that's what I'm doing right now. And also the hardware that hopefully you have in front of you. TJ Van Tol will be next. TJ works with me at Blues as Principal Developer Advocate. TJ is going to start with the Swan microcontroller intro. The reason we are starting with the Swan is that it's really the key to all of our tutorials today. It's kind of the brain of the system in many ways. I will be back to introduce cellular IoT with Blues after that. So we're going to tackle kind of like the IoT part, and we're going to tackle the cloud part, and we're going to talk about the ML part sort of separately, but there's a thread that will bind them all as well. After that, we're going to take some breaks throughout the day. These aren't like rigidly part of the agenda, but we'll kind of like play it by ear and see how things go. Last time we did this, we thought like 10 or 15 minute breaks were useful every once in a while. TJ will be back after the break to get us started with the Notecard and cellular IoT. And then follow through with actually sending our first data to the cloud, possibly another break. Simon Kemper, I don't think is going to be here today. He's the CEO of Datacake, but allegedly, I don't see anybody else here yet. Somebody will be here from Datacake to actually talk about Datacake and cloud dashboards in general. If not, I will happily do that as well because I'm a big fan. And then one of us will go through a tutorial on routing some data to Datacake, building a really awesome, engaging cloud dashboard as well. It's ridiculous how easy they make it. Then we have Owen Jordan and actually David Tischler as well from Edge Impulse. And so they're going to talk about TinyML and Edge Impulse in particular. This is far and away my favorite TinyML service solution. I've used it in many projects in the past. I continue to use it today. It's super cool. Another break in there, and then a combination of us are going to also go through a tutorial to actually build and deploy a custom TinyML model, again, using the hardware that you hopefully have in front of you. At the very end, if there's time, we're going to kind of wrap everything together into one package and start sending some inferences, some machine learning inferences to the cloud to kind of visualize, like, we're going from cellular, we're generating these inferences on the hardware, we're going to send those to the cloud and then visualize those in a dashboard. Oh, and we have Zach Fields here as well. He is our designated support guy here. Hopefully we won't need him at all. Hopefully he's super bored all day today. But speaking of support, since this is a hands-on workshop, I guarantee you things are not going to work exactly the same for everyone. You know, we have people on Mac, on Windows, on Linux, and so there's always some weird thing that happens. But we want to be here to support you as best we can in a one-on-one manner. This is where it gets a little bit confusing, I will admit, but let's start with this. This URL is really important. Please take a screenshot, write it down, whatever you need to do. You don't have to go there yet because this is a link to a separate Microsoft Teams meeting room that we have set up. The way this is going to work is if you are struggling with something, you can head to this Teams room and we'll get you in a room with one of us, whatever the question may be, where we can share audio and video, whatever is needed, and we can help you through the problem. What I highly recommend is in the Zoom settings, when you do this, choose to leave computer audio in your audio settings. What happens is this will actually effectively mute the audio coming from Zoom, so you don't get kind of bombarded with two different audio streams. And of course, during the webinar, during the workshop, you can always use the Q&A panel or the chat panel in Zoom as well, if you have like a more of a simple question that doesn't need a sort of a one-on-one experience. I know this is highly irregular and kind of confusing, but it actually worked out last time. I also know that Zoom recently did add breakout rooms to webinars. It just happened a little bit too late for me to feel comfortable using it. So since this worked last time, we're going to do this again. So it's bit.ly/tinyml-support. And yes, before you ask, we are recording this workshop. You'll find the recording on the Blues YouTube channel at this URL, but also send out an email within the next couple of days, I think, with a link to the recording so you can access it later. So let's actually get started by kicking it off with all the hardware that you hopefully have in front of you. And again, if you are just here to follow along without hardware, that's totally fine. I think it's going to be a less engaging process, but I think you'll still pick up something along the way. But your desk hopefully may look something like this right now, and it's probably a bit overwhelming and confusing. So let's try and break it all down here. First, this is the Notecard. This is a cellular IoT module. It's the core hardware piece that we need to enable communication with the cloud. We'll come back to this later. We'll come back to everything later. I just want you to identify what things are right now. Some of you may also have this black note card. This is a Wi-Fi only note card. This is kind of like a last resort to use if you can't get a good cellular signal in your location. And again, we'll follow up on the specific of this later, but hopefully this is not needed at all. Next down here, we have a Raspberry Pi hat. We aren't going to use that at all today, so you can set it aside. If you have this, I know that we recently ran out of stock on these. If you have one, if you're a Raspberry Pi person, or you have a Raspberry Pi compatible single board computer, it's another way to use the note card with that. But for now, we don't need this today. And these, you'll have one of these. We've provided a variety of different cellular antennas over the last few months. You'll have something like this in front of you, and we'll show you how to hook those up to the note card soon enough. This is the Swan. So the Swan is a STM32 based microcontroller. This is what we're going to be programming today. Next to the Swan is a much smaller board. This is the LIS3DH, I believe, accelerometer. And this is what we're going to use to create our machine learning model later on. To connect the accelerometer to our development board is a quick cable here, which communicates over the I2C protocol. Then we have the Note Carrier F. So this is a development board that lets you connect a note carrier to the Swan together without any manual wiring. And TJ will show you all about that. And here are the all-important USB cables. Hopefully, the ones you have are not charge-only cables. You will need 2 of these cables today. So 2 micro USB cables that are not charge-only cables. And note that when you're connecting the micro USB end, it may get confusing today because there are multiple places that you can insert these micro USB cables. We will be super clear where these should be plugged into and when. And finally, we have a poorly photoshopped in ST-Link debugger programmer. This is new this time. We did highly recommend / require people to also purchase an ST-Link debugger programmer to use in this webinar. It's a little bit confusing to set up because there's just more cables to deal with, but it makes the programming of any STM32-based microcontroller so much easier, and hopefully is going to alleviate any of the issues we had with the last workshop that we ran with the Swan. So let's take another quick spin through just so you know what everything is. Again, cellular note card, Wi-Fi note card, hopefully you don't need it. Raspberry Pi hat, set that aside. Cellular antennas, Swan microcontroller, accelerometer, quick cable, note carrier F development board, USB cables, and the the ST-Link. All right. And of course, I'm going to be repeating this throughout the webinar, but if you need help one-on-one, ask in chat or the Q&A panels, or head to the bit.ly/tinyml-support URL. With that, I think we can get into the hands-on work. So TJ, I will stop sharing here and let you kick things off.
Yeah, and if everybody wants to start while I'm bringing up my screen here, the first step, we're going to be using the Swan. So if you grab your Swan, that's going to be the first thing we're going to do. And then you're also going to want to bring up dev.blues.io, so our documentation site for all things we do at Blues. I should mention too that all of the tutorials, all the guides that we're going through today are also published on our documentation site. So if you do have to leave early for whatever reason, you want to watch the video, these instructions are all written, so you can always refer back to them at a later time. And what we're going to do is start with the quick start. So the quick start is our sort of recommended path for getting started with Blues, learning about all of our tech and all of our technology. And we're actually, for this first step, going to skip step 1. We'll come back to it and start with step 2, which is setting up the Swan. The reason we're doing this, again, is there's a download step that's a part of this. So we like to kick that off first, just in case people have problems with that. We can get this out of the way right away. So if you go into this tutorial, you'll see that as a prerequisite, you have to install Visual Studio Code and the Platform IDE extension. So hopefully you have this installed already. If not, I'm going to bring this up kind of slowly, give you a chance to catch up on this. You can install them using this link. Once you have VS Code, you'll also want to open that up as well. If you don't have the Platform IO extension, if you go into the extensions menu, which is this guy here, you can search for Platform IO. It's going to be a link here. If you don't have it installed, you'll have a little install button. If you click that, it only takes a few seconds. You restart VS Code, and then you'll have this icon down here. And for all the steps in this workshop, I should say just off the top, I'm going to try to go a little bit slow and deliberately. Doing a virtual workshop that involves hardware is kind of tricky because I can't just like quickly poll the audience and ask where everybody's at. So if you do have any problems, we're going to rely on you putting some message in the chat. I'm going to bring up the chat and put it over to the side for me as well. So if something's not working, if something's confusing, I'm going to try to pause like a good 10, 15 seconds after every sort of step I give to give you a chance to hop into the chat. And then everybody else here is going to help flag for me if something comes up that we need to either discuss, clarify, give more information on, and whatnot. So FYI, we're relying on some communication. And even sometimes if you put a thumbs up in the chat, that's nice and reassuring to make sure I'm not just like talking into the internet void as well, that people are actually here and completing these steps is really nice to hear as well. So at this point, you should have VS Code open. You should have Platform IO installed. From there, if you go to the Platform IO extension, which you can do by just clicking this link that should be in the left bar, this is going to open up Platform IO, sort of initialize it. It might take a few seconds as mine is here to load the options. And once this menu opens, this quick access, you can open the home. And then from within there, there's going to be a button to create a new project. So go ahead and click this. For the project, you can name this whatever you'd like. This is TinyML fun, I guess. You can call this anything. We'll be using the same project throughout all of this. So you might want this to be something that you'll remember, that you want to look back at later on. For a board, if you pick the Blues, if you type Blues, you'll get the autocomplete for the Blues Wireless Swan. For the framework, you'll want to leave this set to Arduino. And for location, this is the location of the files that these project, the files behind this project. And you can either leave the default location, or if you're really picky about where projects, where files end up on your computer, you can unselect this. You'll get a file picker. You can put it in your documents or your desktop or your whatever folder makes sense for you. But when you're ready, when you have all of these configuration options in place, you can hit finish. Now, this is a step that could potentially take a decent amount of time because this is what's going to download all of the dependencies necessary to run this project. This process is actually one reason that we really, really like Platform IO, because it sort of abstracts all that complexity away from you. So you're not manually grabbing those dependencies and installing them on your system itself. You're instead letting it take care of it for you. But it does mean if you haven't done this before, which I have, so that step took like 2 seconds for me. But if you haven't done that step, that might take a handful of seconds. So at this point, I am going to pause and look into the chat a little bit to wait and see. Yeah, and Kimball had a good message too, to make sure not to put any spaces in your project name, because we've discovered that will create some problems.
So all my projects have spaces in the name, so I don't know if that's a specific to Kimball's environment, but I guess it's safest probably to not use it.
Okay. So maybe spaces are okay.
Yep.
So you'll know you're good when the project is up, and it should auto open this Platform IO INI file, which is a configuration file for working in this project. If you could give me a thumbs up in chat that you are seeing this, that would be great. Also, if you're in a download step, I'd love to just get a pulse on where everybody's at here. Thumbs up if you're just seeing this and you're waiting. Maybe a comment if you're still waiting for a download or something. You hit some issues going through this. So I see 1 thumbs up. Thank you, Jim, for participating. Thank you, Lynn. A couple more good ones. I'm going to give like 30 more seconds for anybody with problems. This is your chance to tell me that you're waiting. Seeing more thumbs up. That is good. A yes. Excellent. Perfect.
Now might be a good time
to choices. Yeah, go ahead, Rob.
No, I was just going to remind everybody that we're also, if you get super far behind on any of these steps, like don't stress out about it, because we're going to provide links to all the resources as well. So you can go through this like with the video later on and do it at your own pace. Like I said at the beginning, we want to keep kind of a quick pace because we have a lot to get through, but we'll try and pause as much as we can.
Yeah, I'm going to go buy a lottery ticket because we got like a whole bunch of thumbs up. Everything works. So that's a good sign so far. So if you're looking at this configuration file, the next thing to do is if you return to your browser, and maybe I'll just quickly side by side these guys so we can look at both at once. If you scroll down a little bit, because the next steps in the tutorials are going to walk you through what I just had you do. So setting up the new project, this is the bit you need. So you'll find this first block of code to copy and paste. If you copy this block, you're going to need to paste it in here. This is basically the default config we recommend for working with the Swan. The only other change you're going to make, and this is what this warning block is going to say, is because we are using an ST-Link programmer for this, you're going to want to change the upload protocol to ST-Link. So that's basically going to tell Platform IO how we are going to be uploading code over to our device. This is the config. The other thing you are going to need, so there's one thing to copy and paste. There's one other thing to copy and paste. If you scroll down a little bit, we're going to talk about this in a moment, but if you just find this section called Blink the Onboard LED, this is your classic Arduino Blinky, where the code is basically going to initialize the LED that's just on the Swan, and every second, basically toggle the state of that LED, turning it on and off. You're going to want to grab this code and put it in your source main CPP file. So I am going to wait for my computer to let me do this. Dump that in here. And you should be at a point where you have these two files in place. So you have the Blinky code in your main.cpp. You've got the config that is also in the tutorial. You have your upload protocol set to ST-Link. When you reach this point, you're good to go. I'm going to, again, wait the 15, 30 seconds to make sure people are good there, that there are no questions. And then we're going to play everybody's favorite game of which wire goes where. So if you are at this step, it's time to bust out your USB cords. We're going to try to make this as clear as humanly possible. Should be fun. You can also grab your ST-Link, because at this point, basically the next step is we're setting this up to push firmware out to the Swan. And really this step is first because we're going to be using the Swan quite a lot as part of this tutorial. So we want to make sure the process of pushing code to the Swan is all set up and ready to go. And we're just going to test that out by pushing out Blinky. All right, so I am not seeing any comments. So people have had their chance. So it's time to hook everything up. So the first thing you can do is you can take your ST-Link and you should have your, what's the actual name of this cable, guys? Zach, Rob, help me out. The little ribbon that connects to the ST-Link. It's got a name.
I don't know the name off the top of my head. I just call it a ribbon cable.
Okay, we'll go with the ribbon cable. So take the ribbon cable and you're going to connect it to your ST-Link. So there's only one spot on the ST-Link. It might already be connected. I think it might come connected in the box, but the ribbon cable should be connected to the ST-Link. There is only one spot to connect it on there. The other end of the ribbon should be connected to the Swan. And actually, I might just switch my camera real quick. So let's switch my video over to this one and whoop. There we go. Let some focus happen in here. I think this will be a little bit easier to see. Stop the share here. So on the Swan, you will connect the ribbon to this as well. It only goes in one way. That's the one nice thing about that cable. So if it goes in and it slides in, you are good to go. Move some of this other stuff.
And it does leave some unconnected pins on both sides. So don't worry about those.
So you should have this set up. At this point, it is time to get your two USB cables out. Now, one of them is going to go into the ST-Link. So the ST-Link has this micro USB slot. So you're going to need one. Sorry, I'll try to get this centered. Going into there. This is because from Platform IO, we're going to be pushing code out to the ST-Link. So the other end of this cable in a second, you're going to have to plug into your computer or laptop or whatever it is you're using to run this, because Platform IO is going to use this to push firmware out to the Swan. The second USB cable, which I just dropped on the floor, is going to need to go into the Swan itself. So the Swan has a micro USB slot here that you plug your other USB cable into. So these are two different cables. I have them both connected as such. The reason the Swan needs it as well is the Swan just needs power in order to run. So we're going to provide that power through USB. We could provide the power through something like a LiPo battery, but later on, we're also going to want to view the serial logs from the Swan as well. And for that, we'll have to have a connection anyways. So we might as well just do it now and do this through two USB connections. So two USBs in. The other two ends of both of this will need to go into your computer you're using to do this. Again, the reason this one will have to be is for viewing the serial monitor later. So you might have to, depending on your computer, if you're on a Mac, you might have a fun dongle situation to work out like I do. But I'm going to switch my videos and such back over and bring my screen back up and just move some things around again, because I just need to quickly plug in my tube. I've got a old school USB dock that has 10 different ports that I never thought I would need all 10 until I started working here. And all of a sudden I need all this crap plugging plugged around.
You
So
never
you
have
should see
enough
when you plug it in,
USB
there's some lights
ports.
on the ST link. It's a good sign. Yeah, exactly. You can never
Never
have
have
enough.
enough.
You know it's bad when you're like daisy chaining USBs. Like that's when
Hub
you've been
into a
there. It's
hub.
like it's a rough day. So you should have something that looks like this. Hopefully that was clear enough. I'm going to show how to upload and then I'll return to the chat to see if we're good to go. So if you are good there, you just need to upload at this point. That's the one nice thing about using the ST link is once you have the cable nonsense sorted out, it's just like one step to push your code out. You can do that by clicking the upload button in Platform IO. It's this little arrow on the right-hand side. I'm sorry if you have to like squint to see this thing. I prefer there's a keyboard shortcut that is, to me, way easier to use. If you hit on a Mac, it's Command-Shift-P. On Windows or Linux, it's Control-Shift-P. It brings up this VS Code menu that's like their launcher. They probably have some fancy name for it. And if you go into here and just type Platform IO, you can get all the different things you can do from within Platform IO. And upload is the one you need. If you get this little CMake thing, you can just escape out of that. And clicking upload will fire off first a build. So this is taking the C code from our main.cpp file with all the dependencies and all our config and such and doing all the compilation for us. Again, the cool part of Platform IO is this is sort of abstracted away. It's going to do this compile step, and then it's going to do the upload through the ST link. Now, you will know it's working because your LED on your Swan should be blinking, because that's what this really simple sketch here does. We set up the pin. We toggle the pin on and off. So mine is still compiling, but if yours is good to go, this is another check. I'm now bringing up chat. This is another great time to confirm everything is working or things are not working. Thumbs up or thumbs down in chat. And if you're still waiting like me, that's cool too. See some thumbs up. That's excellent. Mine is still compiling. My laptop is taking its sweet time. See, Rob, this is why I need a new work laptop. I need these workshops to run more efficiently.
I was just about to say, Rob,
he keeps asking, I keep denying him.
It's gonna be, I'm gonna expect that expense report coming across your desk here pretty soon.
When TJ started, he got the last of the Intel Macs, and now he's regretting it. So I have no sympathy.
I do want to see more thumbs up though, and maybe other people
could
waiting
still be
like
compiling.
Me. Okay, so mine, I have the blinking LED, so I'll get my camera to focus there. You'll see that like reddish light by the micro USB. That is success. If you see that, pat yourself on the back. You have successfully completed step 2 of this. Basically, you're done with this section. So if everybody could quickly confirm that you're doing this. Okay, I see another thumbs up. More people. More thumbs up, please. Or if something went wrong, this is also the time to flag that. Excellent. Trey, Miroslav, thank you for participating. This is good. Thank you, Mike. We're looking good. Thank you, David, Kimball. As we're playing with fire today. Lynn not logged into platform. Okay, working on it. That's cool. Yeah, if this is taking if you do get behind on this for every reason, like A, the tutorials are available online, and B, you're going to have some time to catch up. Rob's going to go over some slides here for like 20 minutes. So if you want to just tune out Rob for a little bit to continue on it, that's an option you have as well.
My slides are not 20 minutes.
I've got a slide deck with at least 200 slides in it. If you want, I mean, I can roll straight into that.
It is some freeform jazz he's going to start playing.
Yeah. Now, Rob's slides are good, and you do not want to miss them. But if you are a talented multitasker, Alvin, everybody seems good. So I'm going to put this out as your last call to flag concerns or questions. Like if you're curious about what we did, want any clarification about what just happened. If not, like I said, I'm waiting for about 15 seconds, and I'm going to turn it back over to Rob because it looks like everything worked, which is good news.
If you do find yourself in the position that everything didn't work and you're too embarrassed to say anything, you can jump over to the TinyML support over on what's it called, Teams, and I will be there hanging out, just waiting for you to ask the questions.
Sounds good. Yeah, Trey, if you're following along without hardware, that's totally cool too. Again, like what's cool is we'll push out the recordings. You can always go through this later with hardware. But I'm not seeing anybody flag any questions, Rob. So I'm going to pass the baton back over to you.
That's cool. So I hesitated to even mention this because I know the timing was really, really bad for everybody here. But on Monday, we did launch a new promotion to provide 50% off our starter kits. And I feel really bad because I told you all to buy them at full price before that, but out of my hands. So if you don't have hardware yet, there is a discount code that is, let me make sure I can get it to everybody here. Hot-Blues-Summer. If you use that on the Blues store at shop.blues.io, and you're a first-time customer, you can get a starter kit for half off. So throw that out there. Again, I feel bad. I'm sorry. If I had known, we could have started it a week early, but that's how it goes. So, whoops. Again, watch me cycle through all my windows here. And I think this is the right one to share.
Yeah, I got slides in front of me. Yep.
You got slides in front. Cool. So what I want to do is do a quick overview of cellular IoT with Blues. And I always, when I do this, I like to start with our mantra at Blues because I think it really applies not only to Blues, but frankly to Edge Impulse and Datacake as well. So our mantra here at Blues is complexity kills. So this idea is really part of our DNA, and it's really our goals to make developers' lives easier, frankly. And to me, I think it's really easy for us to relate to. I know a lot of us are engineers by trade. And so when we are adopting new and unfamiliar technologies, I want those to help me solve problems pretty much immediately, right? I don't want them to make my life more difficult. So hopefully you see this thread of simplicity run throughout our time together today, and also with your journey with Datacake and Edge Impulse and Blues. So on Blues in particular, if that is our core mission, how do we make that happen as it relates to wireless IoT? First and foremost, our focus is on security. Security is a big thing for everybody these days, and rest assured that one of our main focuses is on securing your data from the moment it's acquired on the device all the way through to landing on your cloud application. Almost as important, maybe just as important for many of you, all of our hardware solutions and our firmware defaults are low power out of the box to the tune of only 8 microamps when idle. We're also, as you're going to see, and maybe as you can get the gist of that already, that we're also very much a developer-focused company. So our developer experience is a top priority, and I think you'll see that play out as TJ does the demo. So looking at our hardware and the service that we provide, this is the Notecard. It is a cellular IoT device. Cool thing about the Notecard, it comes prepaid with 500 megabytes of data, 10 years of global service, all baked into the cost of the device. So there's no subscription fees, there's no monthly SIM fees, no data fees involved. But the Notecard is only half the story. The other half is our cloud service that we call NoteHub. The two work together to form what we call a device-to-cloud data pump. So what does that mean? Well, in practice, you have a starter kit in front of you, right? You're going to hook up a sensor to it. You're going to start reading that sensor data with the host microcontroller, and you're going to deliver that data securely over cellular to NoteHub. NoteHub will then route that data to your cloud application. So to be doubly clear, NoteHub is a cloud service, but we are not trying to make a platform that locks you in. We exist to help you connect to your platform, be it AWS, Azure, Datacake, whatever it may be. So we're really trying to help solve this kind of messy middle piece of connectivity. So zooming in on the Notecard a little bit more, the Notecard is the core hardware that we provide. It is a low power system on module. It measures a little tiny 30 by 35 millimeters, as you can tell. It does have that M.2 edge connector, which we'll talk about in a second. There are both cellular and Wi-Fi variants of the Notecard, which you already know. The cellular one does include a GPS module as well. As mentioned, the cellular Notecard comes prepaid with 500 megs of data, 10 years of global service. You can top them up as needed. The note card has an onboard embedded SIM, but also provides dual SIM support and the ability to switch between them as needed. So for example, we have customers who are building global asset trackers, and the eSIM on the note card is not supported in like China, India, Brazil, pretty big markets, right? And so you can add an external SIM to actually provide true global coverage in unserved markets. And so the API, the way you interact with the note card, it's all JSON based. So there's no AT commands that you need to know, memorize, use to manage your cellular modem. And we provide SDKs for Python, Go, Arduino, C, C++, and Zephyr. And there are also note card varieties that work globally using popular cellular standards. The one you have in front of you is probably one of our wideband note cards that are a little bit more region specific, either the North America wideband note card or the European, Middle East, and Africa note card. So again, everything is JSON in and JSON out with the note card API. For example, if you were trying to get your note card's GPS location, after configuring it, you would send this request, card.location, and it returns a JSON response with the location. And the rest of the API is set up pretty darn similar to this, pretty intuitive overall. So that's all what the note card brings to the table, but I always think it's useful to know what you don't need when you choose the note card for wireless IoT. You don't need your own SIM or mobile plan. As mentioned, the note card comes with an embedded SIM. Likewise, again, to work with a cellular radio, you're not issuing AT commands. You're not managing those cellular connections manually. You're also not rolling your own security. So I mentioned security earlier. The note card itself actually includes from ST, the ST safe secure element, which includes hardware crypto, hardware random number generator. There's also a factory installed certificate provisioned at chip manufacturer. It's also important to know for firmware updates, the note card and note hub provide a really seamless way to update both note card and either ESP32 or STM32 host firmware. So you're not creating your own workflow for that. Power management, as mentioned, all the components in the note card are low power by default. And as you'll see today, is securely sending your data to a cloud endpoint is baked in, frankly, quite simple, but also pretty powerful. And it's also important for many of you who are product designers, the note card itself is FCC and PTCRB end product certified. So in many, many cases, you don't have to acquire a separate certification when using the note card. Now, to make it easier to use your note card when you're prototyping, or even frankly, when you're ready to move to a more permanent solution, we provide development boards that are called note carriers. These let you, as you can see in front of you, kind of snap in a note card and connect to virtually any solution you can dream up. The Note Carrier F, which is the one you have today, it includes a Feather compatible socket. The A model includes onboard antennas. It also has headers to let you hook it up to any MCU that you want. The B is a small form factor note carrier, barely larger than the footprint of the note card itself. The Pi, which you may have in front of you, is a Pi hat for working with any Raspberry Pi compatible computer. And I always like to mention our friends at SparkFun just recently released a new board in their Micromod ecosystem. So it's the Micromod cellular function board. Pretty cool. So finally, in terms of completing that device to cloud story, again, we get to Note Hub. Again, to repeat myself, Note Hub is the Blues cloud service that receives data as a proxy from the note card, and in turn will let you securely route that data to any cloud endpoint. You can manage fleets of devices. You can perform that firmware update. Note Hub is all about security. And I mean secure as in data is transferred off the public internet via private VPN tunnels, can even be encrypted as well. So there's no certificate management required. There's no key rotation that you're going to do. The note card knows exactly where to go as soon as it's turned on, and you'll see that kind of play out today. Finally, to help kind of visualize this whole workflow that I kind of ran through really quickly, I got a quick diagram to run y'all through. So you are going to bring your microcontroller. Today, it's going to be the Swan. But you can use any modern ESP32, STM32, NRF board, many others. You're going to use your sensors, your programming language. We're not dictating any of that. You're going to compose packets of JSON data that we call notes. These notes or events are effectively like arbitrary JSON, and they're going to get queued. They're going to get stored on the note card, and then at a cadence that you specify, either immediately or on a periodic cadence, those are going to sync automatically with our cloud service NoteHub. Now, we don't want your data to live on NoteHub. You don't want your data to live on NoteHub. We want you to send that to your cloud provider. So you're going to be able to route that data, optionally transform it on the fly to effectively any endpoint, right? Now, it's important to note that communication with the Notecard is bidirectional. So you can start in your cloud app. You can send a JSON-based request to NoteHub through the APIs we provide. NoteHub will then securely deliver that payload to a note card, to a fleet of note cards. The note cards will then deliver those back to the host. So you can really easily handle, remote control scenarios, or you can update fleet variables all remotely. So that wasn't 20 minutes. That was more like 12, I think. So I think we can see some of the cellular IoT stuff in action if I hand the controls back to TJ.
Were we going to take a break at this point? Because we had
We could. It's been 45
in
minutes. I got a lot of coffee in me, so I'm rolling. But
okay, do you want to do one more?
One more.
All right, one more. Can you hear my fan in the background? It's a hot blue summer in my office, so I turned on the fan. Is the mic picking it up, or
no? You're good.
We're good to go. All right, so I'm going to switch my camera over then, because the next step of this tutorial is the Notecard quick start. And to run this part of the tutorial, which we'll see if we can get my camera to focus in here, you're going to need the note card and your note carrier. So the note carrier F, this black PCB over here, as well as a note card. And if you haven't already, you're going to need to attach, basically start by attaching the antenna to your note card. Now, you're going to need to make sure to align the different bands on the note card. So the GPS antenna needs to go into the GPS slot on the note card, and the cellular antenna needs to go into the main slot. Now, on this Molex antenna, if you got this specific brand of Molex antenna that doesn't have labels, it's a little bit confusing, but the cellular antenna is the one on the left. And I'm sorry, I'm going to try to not shake this so much. So this one is connected to main, and the right one, GPS, is connected to GPS. And I don't know if I could possibly get that to focus in any better, so I'll just hold it down and point it out. So cellular antenna into main, GPS antenna into GPS. So you want to make sure to get
labeled. That's interesting.
Yeah, if your one is labeled, that makes life way easier. I don't know why they don't all have labels, but we had a bunch in stock that didn't have labels. So that's why I like to make sure everybody can get that up and running.
And you know that my favorite part to call out during that exact moment is snapping on those tiny little connectors actually requires a fair bit of force, at least on mine. You should hear like a little I don't know, like click, or you'll hear a nice little satisfying sound when you get it in there, right? And you will want, if you don't have it actually connected, if it's loose at all, it can affect your connectivity. So you do want to make sure you get it in there good. Yeah, I learned that lesson the hard way, so I always call it out now.
And then once you have that, you'll want to take your note card and your note carrier and insert the note card into the M2 connector on the note carrier. So you end up with something like this. You will need a screwdriver, a Phillips screwdriver, to get the screw out of the mounting receptacle that is on the note carrier. Insert the note card in, and then screw the note card back in to secure it. So we'll watch me awkwardly do that right now. And if any of this is confusing, now's a good time to put your messages, your concerns, your questions into the chat. But you should have something that looks like this. And I don't see anything in the chat. Yeah, after 10 minutes of trying, it's really satisfying. Click to hear. Exactly, follow. That's perfect. So you should be looking at this. So because of that, I'm going to switch back to me. And what you're going to want to do is take your hardware, and I'd go ahead and unplug the Swan and ST-Link from before just to keep things clean. We're going to return to those in just a minute, because essentially for this step, we're going to look at how to use the Notecard. And then as you'll see, the Note Carrier F has these Feather compatible header sockets, because in the next step, we're going to plug in the Swan and then sort of use everything together. But we're looking at how to use the individual pieces first. So if you take your Note Carrier F, and then with one of those USB cables that you freed up, take that and find the micro USB slot on the Note Carrier F, which I'll just do real quick and then hold up. You should see this, and if you notice, my note card started blinking. If yours does, that is a good sign. That means the note card is getting power and you've got everything set up and ready to go. So I'll hold this up a little bit. I'll hold it pretty close so you can even see like the antennas and such. And I'm not seeing any concerns in chat. So I'm going to count to about 5 more in my head and assume that everybody is good to go if I don't see any messages, which I don't. All right, so once you have that hooked up, we're ready to return to the browser. Thank you for the thumbs up. That always makes me feel good. I'm going to share my screen again. We're going to want this screen, and I'm going to return just to my browser. And what you want to do is head back to the main quick start screen. So again, dev.blues.io, our doc hub for all things blues, the quick start link on the side to get these 4 steps. And at this point, we're going to return to step 1 and look at how to use the note card. So when you have that up, go ahead and click the button to start the note card quick start. Now, this quick start tutorial is like a lot of tutorials you'll see just online to alert any sort of hardware, except for this kind of cool section you see here on the right-hand side, which we call the our terminal or our in-browser terminal. And the cool thing about this is you can actually use this to connect to your note card. I should mention that you will need to be in a Chromium-based browser for this to work. So that's because the tech that we're using to make this possible is called the Web Serial API. And currently it is only available in Chromium-based browsers like Google Chrome, like Microsoft Edge, Opera. I think there are a few other ones as well. But you'll need to be in one of those browsers and then click on this USB note card button. And when you do, you'll get this native browser window for connecting to a device that's connected through serial. So you should see your note card here and be able to connect to it. And the cool thing about this is you're forming a serial connection to your note card directly in the browser. And you can use this terminal for interacting with the note card, which we think is really cool. It's just really useful. I use it when I'm tinkering with stuff all the time. And it's our ideal path for just learning what the note card is and how it works, just because it's really, really simple. So within the tutorial itself, you'll want to make sure that you have the Note Carrier F selected. So we have this tutorial available for the different note carriers that we offer at Blues. Rob showed a bunch of them off in slides. So if you do get, if you want to try out some of the other note carriers later, you can always tweak this tutorial and see instructions on how to set that up. And I'm going to scroll past a lot of this. A lot of this is just showing off how to connect things up like we just did. So there's some screenshots that show how to connect everything up, including the antennas and how to make everything work. And if we get down, so here's the instructions for connecting to the note card. What you're going to want to do is find the section called Validate Serial Connection. So either scroll down to that or do a quick search to find it. Because what you're going to want to do is when you find this section, hit the Try It button. So this is just a little convenience function that just takes the request that is from here, puts it into the terminal, and just lets you hit enter. So I'm going to do that real quick. And what happened here is this command actually got sent over serial to the note card. Note that this is JSON. So the API of the note card is JSON in, JSON out. So our request in is JSON that includes a request name, in this case, card.version. And then the note card responds with JSON as well. So in this case, card.version is just like your whatever, your info or your generic version information, where I'm just getting firmware information about the note card, what type it is, all that sort of different metadata that I want to work with. But we'd like to include this example first, just so you can see a really simple example of what basically communicating what the note card looks like. You send in JSON, you get JSON back, and we're going to build on this with some more complex commands, but this is the basic workflow that you're going to be using for communicating with Notecard. I should mention too that we're starting by sending these commands over the browser, but you can also send in these requests using either the Notecard CLI. So we have a CLI that's available for Windows, for Mac, and for Linux. And you can also send in these requests using our different firmware libraries that we have available. So you don't need to bring this up, but I'm just going to show real quick that we have a section in our docs on our firmware libraries, and they are available for Arduino, for Python, Zephyr, C, C++, Go, TinyGo. There's a couple other ones as well. So essentially, what we're going to do is for now, we're sending these requests through the browser to learn the note card in isolation. And then here in a minute, we're going to look at how to use a firmware library on the Swan to talk to the note card in more of like a realistic firmware environment on an actual microcontroller. All right, so we are at this point, we've connected our note card. We've sent data to and from the note card. And if we scroll down, you'll see the next thing we want to do is actually start working with data. Chances are you want to use the note card for something more interesting than metadata. And to do that, you will need to set up our cloud backend NoteHub. So if you follow this link, or if you just go to notehub.io, you can find NoteHub. If you haven't already, you will need to set up a free account on NoteHub. It's totally free to sign up for. You just need an email and password. And if you haven't, I'll wait like 30 seconds here and check the chats just in case for people that do need to sign up for an account here. And then once you do, we're going to go ahead and create a project. Going to check the chat. Rob, has anything come in? Any concerns? Anything I've missed so far?
David had mentioned the noticing that the firmware version on his note card was older, 352. That's totally fine. If you happen to have a note card running like a version V1 of the note card firmware, I'd be concerned. But anything relatively recently, and especially if you just purchase a starter kit, you're going to be fine.
Yeah, everything we're doing here today is not using like cutting edge note card firmware features. And in general, we try to be really, really good about being backwards compatible and making sure even older firmware works with all of our services and such. So shouldn't be any concern. All right. Last chance to speak. Any concerns? At this point, I'm assuming everybody has a NoteHub account set up. You're probably looking at it more of an empty list. I've got since I work here, I've got a kind of a mess in here that I need to clean up sometimes. But what you'll want to do is create a new project. So I'm going to name this, you can name this whatever you want. I'm going to name this the same thing I named my Platform IO project because I like the consistency, makes my developer brain happy. Set this up. You can name this whatever you'd like. You don't need to do any further configuration. Just give this thing a name and hit create project. In NoteHub, in our cloud backend, you can think of projects as just logical groupings of things like devices and settings for the things that you are building. And to start, we're going to explore a lot more of what you can do in NoteHub throughout this workshop. But for now, all you really need to care about is this identifier. We call this a product UID, and this is just a unique way of referring to this project within NoteHub. So you get this button to copy it to your clipboard. And then if you return to the tutorial and scroll down just a little bit, so here's the screenshot of copying that, you'll see that the next sort of copy and paste friendly command in here is what we call the hub.set request. So if you hit try it once again to take this hub.set, to bring it down to your in-browser terminal, you'll need to take this product and replace it with the one you just copied. So I'm going to paste mine in here. And then when you have that, hit enter. And this is the request that essentially tells the note card, associates the note card when you need to work with data, what cloud backend am I interacting with, and give it this identifier so it knows which one. Once you have that done,
sorry, TJ, I was just going to mention if you're using, and I can't remember, I apologize, I can't remember which version of the note card firmware you need for this, but if you see at the top of TJ's terminal, it says sync needed, NoteHub sync failing, waiting for wireless service. You'll see that status update if you're using a recent version of the Notecard. If not, anyway, TJ's instructions will be here, but just so you know, like you'll get a kind of a live view of what's going on behind the scenes at the top.
Yep. This is one place where having a newer firmware version will help you, because one of the things we added is just more like internal stuff so that we could track it in our tooling, things like this. So if you have an older version of the firmware, all this stuff is still happening, but the terminal might not be able to pick up on it and give you just better reporting on exactly what's happening. Now, once you do make this configuration, so I've associated this Notecard with my backend. The Notecard by default isn't going to take that change and push it up to the cloud immediately. Instead, you need to actually synchronize that change with the cloud. So there are a number of different ways you can configure your Notecard. So you can configure a Notecard to have a continuous connection to the cloud and basically automatically sync changes as soon as they happen. Or because the Notecard is a low power friendly device, if you're planning on eventually running your project off of battery power, you could also configure the Notecard to only fire up the modem and synchronize with the cloud every X minutes or X hours or even X days, depending on whatever it is you're building. But the default setting does try to be conservative with battery usage and will not automatically sync changes. So you either need to configure the Notecard differently, or the easy way and the demo-friendly way is you can always run a request called hub.sync, which will just immediately synchronize any changes that have been queued up on the Notecard, as well as any changes that have been queued up in the cloud, and basically reconcile them. So when you run this, this will actually fire up the cellular modem on your Notecard for the first time. You'll see in here, it's actually talking to the wireless service and pushing this change out. It will tell the cloud that this is a new device associated with this project and push it out. This is the moment too where if you have any connectivity issues wherever you're located, that'll depend on how long this takes. When you do get done, you can go back to NoteHub, and when you refresh, you should see your device on the list. So you'll see mine listed here. Once you see it here, and you'll have to refresh in order to see it, you know you've made this connection, that you've associated the device, the physical device sitting on your desk, with your cloud backend. Another thing you can do, so I'm going to give people a second to make sure everything connects and works, but you can double click in your device. Awesome, Lynn. Yeah, this is very cool. I think like it's worth, every time I do this, you get kind of numb to it after a while working here, but if you think about what just happened, it's kind of amazing because you are communicating over cellular and you didn't have to work with the cellular modem at all. You didn't have to configure any of that. You didn't have to run AT commands. There's a lot. You didn't have to sign up for a cellular service or a cellular plan. So it's kind of cool that this is possible. You can also double click into your device. And if you just scroll around, you'll see that the Notecard also has in here, picks up some metadata as well. Actually, we'll return to this after we send our first data. But at this point, you should see your device in the list. And I'll give about 15 seconds. If anybody is not seeing their device listed in Notecard, please drop something into the chat or the Q&A so we can help you figure it out. We occasionally run into problems of this of people trying to run their device in like some sort of like basement setting or someplace where you just don't get good cellular connectivity anyways. And if that's the case, sometimes you can have trouble making this connection. But I'm not seeing any concerns. So I'm going to assume that everybody is good to go. And the cool thing is, once you've established this connection between the physical Notecard that you have and your cloud service, you have everything you need to start working with data. So if you scroll down a little bit further in this tutorial, we're going to find the next section called Queue Notes to your Notecard. And this has the next of our requests, which is the note.add request, which is the simplest way of sending data from the Notecard up to the cloud. All the request takes is a body, and the body can be just an arbitrary block of JSON. So in this case, we're going to assume we have temperature and humidity. We probably have the Notecard connected to some microcontroller that's reporting on temperature and humidity and pushing it through. And we're going to push this up to the cloud. We're going to start by sending this request with this hard-coded data at first. And then in the next tutorial, we're going to look at how to get some actual data for this and look at how to push that up. But for now, go ahead and click the try it button to put this note.add into the terminal. Hit enter once more. The note card should reply with this total. This is how many notes have been queued up onto the note card that have yet to be synced with the cloud. And once again, the note card is not going to automatically push this up to the cloud. The config is low power friendly by default. So we're once again going to need to run a hub.sync request, which handily we have a one right down here in the tutorial that you can run. This is all again, fire up the cellular modem on the note card. It's going to take this temperature and humidity and push it up. And where you'll see this one is if you return back to your project and go to the events list, you'll already see some of the metadata that's been coming in from the connection you made to the note card. And then once the sync of this happens, which I think it just happened for me, if you refresh, oh, maybe it didn't happen quite yet. Oh, there it goes. I think if I refresh one more time, I should see it. Yep, there it is. You should see one of the entries in this table called a data QO, just the name of what we call a note file, and it should have that data that you pushed up. So in this case, that temperature and humidity. And for this one, if you do double click into this, so I've got this data QO selected, I'm going to double click into it. You can go to the body tab if you just want to see the sort of body of that note.add that we pushed up. But you can also go to the JSON tab and see some of the other metadata that was collected alongside of this. So we collect some identifiers, a timestamp, a location. So by default, this is going to be the closest cellular tower that I have here. The note card also has a GPS module built into it as well. So you can configure it to take GPS readings as well and associate those with your readings if you'd like. And we have all sorts of features related to that. But just even by default, it's going to give you a rough idea, in this case, of the cell tower that handled this request and where that is located. And I'm going to return back to the chat one more time just to make sure everybody is also at this point. It worked also in Waverly, Michigan. That's funny. We use some service to get those location names, and it's convinced that this is Waverly, Michigan. I'm in the west side of Lansing, so Waverly it is.
I would just add here, in case anybody's watching this now or on a recording, like if you're having trouble with getting a cellular connection, there's two suggestions. There is a help doc that we have that walks through a bunch of common scenarios for why you might not be getting a cellular connection. David in chat mentioned like one of the antenna wasn't properly snapped in. That's a common one. Even just placement, like by a window or not, can help. Also, this is an opportunity to use that Wi-Fi note card, and there's a separate help doc for getting that because there's an additional command you need to use to configure it to connect to your Wi-Fi access point. So there's all sorts of workarounds that you can do, but just so you know, those are options.
Yeah, if you go with diagnosing cellular connectivity issues, I think it's easiest just to search for it up here. You can find that guide, which walks you through that. And at this point, this is really all that we were going to show. I'll just point out real quick at the end of this that this quick start tutorial just tries to show data flow from the note card, from the hardware up to the cloud, up to NoteHub. But the communication between the two is bidirectional. So when you establish that connection, you also have the ability to push down notes or changes to the devices as well. So for notes, that means you could put up a note on NoteHub that maybe works with a light bulb, says command turn light on. And then with the note card runs a sync, it could pick up on changes coming from external, coming from the cloud that you could use to sort of command and control devices is another approach that you can take as well. And we'll look a little bit at that, show off a little bit of how that works in the next tutorial as well. But at this point, Rob, I think we are probably going for a break, I imagine. Cool. So the next step in this is going to be what we call step 3 in our Blues Quick Start. And I'm actually just going to switch over because we're going to start by doing some more hardware setup. So I'm going to switch back over to my camera so that we can get everything hooked up. So the last 2 steps that we covered, so we set up our Swan, which I've got over here to the side. And then we also did the setup on the note card and note carrier. And so this step is going to be putting all the pieces together. So we looked at how to send data from the note card, but we did that with just some sort of basically hard-coded data, right? A temperature of 35 or whatever. So this time we're going to generate some real data and use the Swan to talk to the note card to send that up to the cloud. Now, since we're putting this all together, we're going to start by literally putting it together. So you'll want to take your Swan and insert it into your note carrier F. You want to make sure you align the correct side so the header pins line up. It should slot in fairly easily. Look a little something like this. And then we're once again going to need to play the USB cable games. And this is the most important one to pay attention to because there is an incorrect slot this time for working with this. So I'm going to grab my cables and show this off somewhat slowly. So the first one you need to do is you do need to provide access to the ST link. So the first cable is going to go into the ST link. So again, we're going to be pushing out firmware to the Swan using the same process we used in the first tutorial we went over. So that is the first USB cable that you need. The second USB cable is going to again go into the Swan. So I'm going to plug this in over here. Noticing that the one area that I am not providing USB to is to the note carrier. So this is going to more resemble the first step we did, where we need a USB to the ST link to push out the firmware itself, and we need a USB to the Swan to provide power to the Swan, and also because we're going to be reading the serial logs from the Swan as well, so we also need a cable in there. So just one last time to be incredibly explicit, USB cable into the ST link, USB cable into the Swan. Both of these, like we did in the first step, and I'm just going to do this myself. See me play the monitor swapping games here for a second. Plug both of those into your computer. So I'm going to go and reach over and plug both those in. When you do provide power, the one to the Swan, you should again see the note card. You should see lights on both the Swan and the note card kick in to make sure everything has power. And once that is done, I need to bring my screen back up. And what you're going to want to do is, with the hardware set up, head down and scroll down to, so we did step one, we used the note card to send data. We started the day off by setting up our microcontroller. We're now on to step three, the part where we put everything together and learn how to write firmware using the Notecard SDK. So go ahead and click into that. You will want to make sure, you'll see that this tutorial, one thing I should mention too is that we're using the hardware that comes with the Blue Starter Kit, because that's sort of our opinionated best way of getting, our easiest way of getting started with the note card. But the note card is designed to be a general purpose device that you can plug in and use with just about any IoT hardware out there, or even spin your own board around. So you'll see that you can configure this tutorial to work with some different ecosystems. So later on, if you want to return here and you have another MCU or some other type of hardware you like working with, this is a great place to go to configure these options and learn how to use the note card in a slightly different way. But for today, you want to make sure that these things are set to the default, which should be C, C++, Arduino, the Blue Swan, and the Note Carrier F. So you want to make sure those are set accordingly. And then you can scroll down a little bit. So there's some here that is, again, going to walk through what I just showed. So setting all of this up. Creating a Notehub project, we can skip this. We can just use this project that we already have in here. We'll just continue to use the same one. So I'm going to continue scrolling down past here. Some of the setup is something we've already done as well. So creating a new project in Platform IO, we're once again going to continue to use the same project that we already have. And in fact, what you might want to do is, because we're again going to start working with code in a minute, find your favorite monitor setup so that you are ideally able to both look at the code as well as the browser. So I'm going to have this side by side to make my life a little bit easier as we go down through this. This tutorial is, again, because we want you to be able to do this tutorial in isolation, has this config. You can just leave what we already have. so there's no need to touch that. The first thing you will want to do, and I'll pause here for a second so you can find the same scroll position as me, is this line that has you include notecard.h, which is going to be a reference to the Notecard's Arduino firmware library. So you'll want this step up first, and you'll want your main.cpp file up. You probably also want to, let's go ahead and just gut the setup and loop function in here, just so we're operating. We have a completely blank slate we're working with. I should also mention too that the Arduino sketch here, if you are completely new to Arduino, it's a pretty easy setup, but there's really just two functions built into Arduino: a setup function that runs once where you provide your setup, and a loop function that's going to run continuously. And the idea is that you run any of your configuration in here, which is, this is what we're going to do first, is put the configuration of the Notecard. And in our loop, we're going to do the bit where we actually take a sensor reading, send it up to the cloud at some interval. So we're going to start putting these things in. Let's grab this include first. This is a reference to the Notecard firmware library for Arduino. And this library is actually already installed because in our configuration file, we have this libdeps library dependencies. The Notecard is part of that default config. So this is what tells Platform IO, bring in the Notecard's firmware library, build it alongside of my firmware to make it available. And all we need to do is include it so that we are able to use it. So that's what we do here. Next, if you scroll down, we're going to grab a define of serial that we are going to use for logging. We're going to grab a define for the product UID. So we are going to set up something very similar to what we did in the browser. We are going to connect this Notecard to a backend NodeHub project. And because of that, you're once again going to need to take this placeholder and replace it with your own value. So if you go back to your NodeHub project, you can get the product UID if you don't already have it handy somewhere in the settings. So NodeHub project, settings, and it is going to be right here. This is the easiest way to copy it. Grab that, paste it in here, and I'll hold that up for just a second. So product UID from NodeHub, bring it into our firmware, because essentially we're going to be doing a very similar thing to what we did in the browser in the last step. But in this case, but this time we'll be doing it from Arduino firmware that runs on the Swan. So product UID, can head back to our next step. I'm going to scroll down a little bit. I'm going to get this reference to the Notecard. So this is coming once again from the Note Arduino, our Notecard firmware library for Arduino. We're just going to get a reference to a Notecard. And then within setup, we're going to start the serial debugging so that we're able to look at some things in the log, place that at the top of setup. Right below, we're going to do notecard.begin, which we'll place right after this. This assumes, and Zach can correct me if I'm wrong, I think the default of this assumes an I2C connection to the Notecard. And because you're using the Note Carrier F, all of the wiring, all the connections needed to make that happen are just done by default. But if there are different ways you want to wire or connect to the Notecard, there's different parameters you can pass to this to configure it in different ways. But one of the reasons we're using the starter kit, we're taking the happy path. Basically, everything is wired for you. So we can just start up the Notecard and get it ready to go. We set up things for debugging. So we'll view the serial monitor, which we'll see here in a second. And then finally, we're going to use the Arduino library to make a request to the Notecard. So I'll paste this in at the bottom of setup. And this is going to be doing the exact same thing we did in the browser, where we send a hub.set JSON command over serial. This J is just some helper functions and libraries, as well as this for working with JSON and C code that we provide. And this is just going to formulate up that same request, take that product UID and set it. This time we're going to set a mode to continuous. So this is telling the Notecard to maintain a continuous connection to the backend. We're doing this just to make the thing a little bit easier to demo and to test. But if you are also eventually running Notecard-based projects and you're not concerned about power, you might also want to set it to continuous mode just so you can see your changes that you push a little bit quicker. And with that, and then the Notecard that send request is what actually commits this to the Notecard. So at this point, we can actually take this and make sure to save it. And we will push this out to the device. So once again, you can either hit, if you like buttons, there's the upload button down here. If you like keyboard shortcuts, I like Command Shift or Control Shift P to use the upload function. There's also, if you're really good at memorizing things, you could memorize this and make your life even easier because we're going to be uploading a handful of times here. But go ahead and hit upload to push this code out to your Swan. This is once again going to build your project with these new changes. This one should go a little bit faster because it should have cached everything from before and push that out to the device. So you should see a success here. And then I'm going to show one more step, and then I'll pause to the chat to look for potential if anybody has problems in here, because I also want to check viewing the serial log. So the serial log just gives us a little way of just ensuring everything is working correctly. And we set this up through this line here that sets a debug output stream for the Notecard. So if you go to the serial monitor within Platform IO, which is this, once again, I'll show both approaches. Oh, it's actually this little plug. If you can make out that 10 by 10 icon at the bottom of the screen, it's a little plug looking thing. Or once again, Command or Control Shift P, and you can find or type in Platform IO serial monitor to bring this up. This is going to show the serial monitor from the device. You might have to, because the log, the only thing we're going to see in the log is happening on setup, which is already run on the device. But one little trick you can do, you can press the reset button, RST button on the Swan to reset it, which should run through my thing again so that I can see the log. Although it's not working for me here, so I might need to restart it real quick to see the hub.set. But really all you should be seeing is the hub.set coming off of the Notecard. Let me make sure I'm monitoring the right thing here. If everybody's seeing the log, can you throw it in chat so I feel a little bit better? I'm going to try this one more time. I also have a second serial monitor I could bust up again. Let's see, serial monitor. And then I'm just going to upload again to push this code out and see if we can see that hub.set. So if you are getting this to work, if you're pushing this out successfully, I'd once again appreciate a thumbs up to make sure everything's good.
I think it's looking at the wrong serial port.
The wrong port.
Yeah.
How do I configure that in here? I could also run the serial monitor.
There's a
extension.
Platform IO configuration for it, but you're probably best off using the serial monitor extension. It's a good time to talk about it.
So there is another extension that you can get for VS Code that's, I believe, from Microsoft, just called Serial Monitor. And we find it works really, really well. And I have it available as well. So what I'm going to do is use that one real quick, just so we can see it. And this works independently of Platform IO. And I think we'll try them both real quick. So we'll start monitoring it. Reopened. Okay. So yeah, Platform IO serial monitor was connected to the wrong port or something. But when I use the serial monitor extension, this is what you should see. The hub.set, this is the debug output stream from the Notecard. And the response, the return value you'd expect from hub.set is just an empty JSON object. That just means everything worked successfully. Yeah, Mark's helping me out with the monitor port. That is the correct way of doing it, setting the port you want to monitor in your config file. So that is in the chat. Thank you. Paulo asked a good question too, of any benefits of using Platform IO instead of the plain and simple Arduino IDE. We find it does a little bit more to help just automate things, some of the library management, the config. So in Arduino IDE, I know there's a big menu at the top where you have to set all the options. And we like just being able to provide a single INI config file so that you don't mess any of that stuff up. Rob, do you have any other, what are other reasons we like Platform IO? I know there are more.
That's primarily it. I mean, it's really like it's maybe more of a beginner oriented IDE. I mean, which explains why I like using it a lot. It just kind of like simplifies everything. However, as you take that next step, there may be certainly cases where the Arduino IDE, especially the new version 2, is quite a bit improved over V1. But yeah, I think we just want to provide the smoothest onboarding process possible, and that we've decided is Platform IO. I know I had somebody reach out to me before the workshop started asking about using the STM or SD Cube IDE as well, which is another option that even takes it up a further notch if you're like a professional, in quotes, ST specific developer. But yeah, there's a lot of options.
And the thing is too, all of them will work with the Notecard. So if you're done with this workshop and you hated Platform IO, then by all means just switch to Arduino IDE. Like we're not coupled to any of these platforms. We just like to pick one for the purposes of the workshop. Just to, the more we can get everybody doing the same thing, the easier it makes it to make sure everybody's going through the same experience. All right, so at this point, our next step, so this is the config of the Notecard. So at this point, when the Swan boots up, it's going to configure the Notecard, tell it what project it needs to synchronize data to. But at this point, we need to start actually sending data. So if you scroll down to the tutorial, you'll see the next thing that we are going to install is this library that we call the pseudo sensor library that we have available for Arduino, that is going to take a mock humidity reading and a real temperature reading. So it's using the Notecard. The Notecard has a built-in temperature sensor on it that it's going to take a value from that, and it's going to make up a humidity value to go with it. The idea being it's a library that's going to give us some sensor data that we can use to sort of test and learn how everything works. So to install this in Platform IO, if you go to the Platform IO menu, there is this library section from the quick access. So I'll bring that up, show it here real quick. You'll want to click that. Within this search box, if you search for Notecard and you scroll down a little bit past the Arduino library, you'll see a second one for this pseudo sensor library. So you'll want to take that and click on it. From there, there is this add to project button. So you'll want to click that. And if you're like me and you have a bunch of these, you'll have to find the right project to add it to, and then scroll down and hit add. Now, what this UI is doing, it's actually just a really nice way of adding something to your Platform IO INI file, because you'll see that after I went through these steps, if I go back, and I'm just going to consolidate things here for a second. If I go back to Platform IO INI file, at the end of the day, that UI just helped me add this line of code that added another library dependency to my build so that I'm able to access it. But the Platform IO UI is a nice way of just seeing how to install Arduino libraries when working with Platform IO, because after this, you might want to install one for working with a different sensor or whatever the case may be. And that's sort of the process that you can go through. All right. I'm going to scroll down a little bit, because now that we have this library for working with this pseudo sensor library, we want to use it. So we're going to, again, grab the include for it. So you'll want to scroll down to find this include of the Notecard pseudo sensor library. And then once you have that back in the main CPP file, you'll take that include and paste it up here. Next, we're going to need a namespace, some classic C code for working with the sensor library. And you can just drop that in up here on top as well using namespace blues. Below that, we're going to initialize the Notecard pseudo sensor. This thing takes a reference to the Notecard itself. That's because, again, it's going to be using the Notecard's onboard temperature sensor to get the readings. So we have to pass a reference to it. So take that line of code, put it right below the Notecard. And then down in loop to start, we're just going to log out the different sensor readings that we're taking and loop them out and just spit them to the log to make sure that works. So if you have that, go ahead and once again, upload. So either the icon or the command, we want to make sure that we are getting these logs through, and you should see a temperature and humidity reading in your log every 15 seconds. This will once again take a little bit of time to compile again, because we did add the new library. So this is where Platform IO is going to get that, and it has to rebuild, do all the binary steps to compile and build all this together. So it should take, it'll probably take a minute or so to build, and then we should see some temperature and humidity in our monitor. But because we have to wait for a minute, now's a good time to ask any questions you might have, anything you might be confused about. I'm going to use this to get caught up on the chat here a little bit.
There was a really good question that just came in from Mark. The question was that at this point in the setup method, the mode is set to continuous, but nothing yet in the loop. How much data is being used against the 500 megabyte allocation for the note card? The short answer is hardly anything at all. Basically, the note card is going to make one cellular connection and maintain that. And by maintaining it, it's basically like every 20 minutes, it's going to do a ping, which is like, I forget what the total, it's like 20 kilobytes out and back. I think that's right, every 20 minutes. But there's a document that actually I put together a little while back that estimates data usage in a variety of scenarios. And I don't know if everybody saw my answer or not, but I'm just going to post a link to this doc because it is kind of useful. It's nice to see how little data actually gets used for many common scenarios.
Kind of. I know it's in here somewhere, Rob. I gotta remember what to search for. It's the data usage estimates. There it is. Yeah. Or just follow Rob's link. That's easier. So when you have it built and have it out, you can see your readings. Apparently it is 27 degrees Celsius in my office, which I have to convert that because I don't know what that means. It's 80 degrees. That's why I've got this towel here, man. It's been, I don't have the AC on, so heating up in here.
EJ,
so
that's
hopefully,
nothing.
Yeah, David, we were talking before this. David's in Phoenix, where I think he's currently like on the surface of the sun, more or less.
No, it's only 100 right now, but we'll hit 117 today.
Crazy. All right. So last, I'm going to do the whole give you 15 seconds. If for whatever reason you hit a problem, you're not seeing the temperature flowing through into the logs. Once again, the humidity value is made up. So this means nothing. We just put it in there so you have a little more data to work with. So that should not be a real value, but temperature should be. And I'm not seeing anything in the chat. So I'm going to move on to the next section of this. And at this point, so we've done our setup of the note card. We have a loop where we're getting the sensor readings. Right now, we're just printing them out. As a next step, we're going to take those readings and start pushing them up to the cloud. So if I grab this next chunk of code, so I've scrolled down to this send sensor readings to the note card section, and I've got this chunk of code that's going to run this note.add. Again, this is the same basic thing that we ran from the browser, but this time we're going to take those real values, or at least that real temperature value, and start pushing that up. So we're going to do that, and we'll paste it into our loop. I'll put it right before the delay and paste that in there. And the only other flag I'll point out in here is we also have this sync true flag. This is another very demo-friendly flag because it's telling the note card just immediately run a sync when you add this note. It's a handy one to use when you're testing, or if you're not, you have like no real power concerns for working for the project that it is you're building. If you are building something low power, you probably wouldn't want to do this unless it's something you like, some sort of alarm or something that you need to immediately send out. So I'm going to do that, and then we're going to push this out one more time. So once again, Platform IO upload. You'll see we're going to do this, I think, one more time. So you'll start to see the value of memorizing the keyboard shortcuts the more we do this. And we'll be using the Swan when we start building in the ML stuff here later on as well. So it's worth it to commit some of these things to memory to save yourself a little bit of time. All right, so we push that out. We can check our serial monitor to see if we're pushing, if this is working correctly. It's every 15 seconds, so we might need to wait a few seconds to see anything. But what should happen is as you're running this, so here's the note.add that just ran. Again, the total is how many notes are queued on the note card that have yet to be synced. So this is probably going to show one, if your note card is having trouble connecting to the tower at all, that number might start to go up because you're queuing notes onto the note card, but they have yet to be synchronized up to the cloud. If that number is staying at 1, which I am seeing here, that means they are being synced. So what you can do is go back to NoteHub and go to your events page. And if you refresh, or actually I didn't need to refresh because I just went to the events page, I can see the temperature and humidity readings sort of rolling in. And this is kind of the picture of, this is sort of the high level overview of what the Notecard makes possible, because there are a whole lot of IoT projects out there that fit into this sort of paradigm, even if it's not using the exact same approach, where basically you connect up your hardware, you're gathering some sort of data, weather data, location data, accelerometer data, who knows what you're sensing. You configure some sort of interval, whether it's continuous or maybe like every hour, maybe every whatever, and you synchronize that data up to the cloud, which is what this project is now doing. So I am going to, I wanted a good question too about, for low power, do you have any other recommendations? So I'll cover that in just a minute. At the very end of this tutorial, we talk about how if you are going to be running in low power, how you would change this up. So if you're not operating in a demo setting, so I will put a bookmark in that and we'll come back to that here in just a second. I'm going to wait 15 seconds here again. This is your chance to voice any concerns you might have. If you are not seeing data flowing through to NoteHub for whatever reason, now is a good time to flag that. If you just need a few more minutes, or if something went wrong, some problem, any errors you're having, please reach out and let us know. I'll give you a second to do that, because we're going to look at one last feature of NoteHub here in a second that I think is pretty cool too. I'm not seeing anything else in the chat. That's good news, because I think everybody is up and running and seeing data. And the last feature I want to show, and I'll just scroll down to the tutorial to show you where this is, because you'll actually have to skip down a few sections to this section on use environment variables. So when we were in the Notecard Quick Start, I talked about how the Notecard can synchronize data in both directions, and how to this point, we've only been pushing data from the device up to the cloud, but that there are definitely situations where you might want to send data or settings in the opposite direction as well. So I mentioned then that one thing you can do is send notes from the cloud down to a device. But another feature we have that also makes use of that bidirectional communication is one called environment variables. So environment variables are basically key value pairs that you can synchronize across devices, across even fleets of devices if you're working in a pretty large scale deployment. And what we're going to do in this demo for this last step is introduce an environment variable so you can just see what one is and how one works, and maybe get some ideas of how you might want to utilize them in your own projects. So what I'm going to do is I am going to, let's see, we're going to go back to NoteHub. Now, environment variables, you can set at multiple different levels of your project. You can set them for an entire project. You can set them for a fleet. You can set them on different devices. You can set up different hierarchies. So you have like project level variables that different devices can override or different fleets can override. So there's a decent amount of complexity that you might want to do for larger scale deployments. But for today's demo, we're going to keep things pretty simple. We're just going to set a single environment variable on a single device. So if you go back to your devices screen in NoteHub, you go to your device, you double click it to go into the devices screen. You'll see that there is a tab for environment. If you click that and find the device section of this, so this is environment variables that are specific for this device, define a new one called reading interval, and we'll set it to 30. When you have that in place, go ahead and apply those changes. What this is going to do is set an environment variable on the cloud. So you're setting this on NoteHub, but because the connection between the device and the cloud is bidirectional, we're going to look at how the cloud has the ability to push this change down to the device. So reading interval 30, I'm going to leave this up for another 5 seconds here just to make sure you've got this set on this device in NoteHub. And I'll also show you that the tutorial walks you through this, right? So I'm showing this, but if you're following along later, you'll see these instructions are all in here as well. So you can continue that way also. So we have this set to 30, but we now need to pull that data down because just setting the variable doesn't mean much. We're creating this reading interval to replace this value that we have hard coded in here. So right now our project is taking readings every 15 seconds. But the idea is, what if we took this device, we made it low power friendly, we threw it out in a field somewhere, and suddenly it's a month later and our business decides, oh man, every 15 seconds is no longer cutting it, or maybe it's using up too much power and we need to change it to every 30 seconds or every 45 seconds or whatever. Environment variables give you a way of configuring these things without having to update, say, the full firmware of your devices. And also because you have a cellular connection, you can push out these changes just remotely over cellular at any time as well. But we need to get that value because we're hard coding this. And how do we get the 30 down onto the device? Well, that's what this code right below it is for. So you'll want to go to this using environment variables in firmware section and grab this chunk of code for getting the sensor interval. So you'll want to copy this. You can paste this one in at the very bottom of the file for getting the sensor interval. What this is using is another of the Notecard requests. So you start to see a pattern here, right, for using requests in code. So we did hub.set, we did note.add. This is env.get, env being for environment variables. So there's different ways you can configure this, but in this case, we're saying just give me one variable, the reading interval, because that's the one we configured. There's a little bit of C code then to convert that into an integer, because that's what we need to read. And there's a default in here. So just in case people haven't set it, it sets it to some default value. So this is going to get the sensor interval. It's going to check the environment variable. To use it, we're going to put in a couple lines of code. We're going to grab this declaration of the function, this get sensor interval. This is just a little bit of C code that lets us use this function basically in any order. So I'm going to toss it. It doesn't really matter, but I'll toss it right up here on top. So that function is declared. You want to grab that. Below that, step 3, if we go down to our delay, so the delay at the bottom of the loop. So the delay that's currently hard-coded to 15,000 milliseconds or 15 seconds. So I'm going to paste this in instead. So now we're saying instead of hard coding every 15 seconds to do this, instead get that sensor interval from an environment variable and use that in the delay instead, and also log it out so we can debug and check and make sure everything is working correctly. And lastly, the final step of this whole tutorial is we're going to need this one additional sync flag that's part of our configuration for hub.set. So it's this line here. You'll see that it's next to this comment that says add this line. This is setting sync to true on the hub.set. And what this does is it tells, this is another demo friendly thing that basically says, as soon as an environment variable changes in NoteHub, immediately sync that or push that down to the device. This basically tells the Notecard to constantly look for environment variable changes. More realistically, you would probably set up your device, your project to passively get these changes at a certain interval, but we don't want to wait that long as part of this workshop. So we're setting this sync flag true so that we can get that change right away. And once we have this, for one last time in this tutorial, you can push this code out to your device. So you can do an upload and push this out. And what we should see, so I'll bring up my serial monitor once this loads. What you should see is that this m.get request gets loaded, and it should pick up on the 30-second that we configured in the cloud. So this is pushing it out. Success. I'm going to switch back over to my serial monitor. I have this in. I have my node.add. There's my env.get that's happening. It's delaying to 60 seconds. I think that's because it hasn't picked up on the change from the cloud quite yet. So I'm going to have to wait a minute. And then the next sync, it should find this 30-second reading interval and pull it down and wait 30 seconds. So let me know in the chat if you are seeing this. Hopefully, if you're luckier than me, your first run at it picked up the 30 and you don't have to wait an additional 60 seconds. I see a thumbs up from Mark, so thank you. I probably should have set this, speaking of demo friendly, I totally could have set this default to less so we wait less time. That's okay. This gives us a chance to catch up on any questions or any concerns people have. Still 60 seconds. Did I, let's see, this might be a connectivity thing or it might be me spelling something incorrectly. Are other people seeing 30 seconds getting pulled down appropriately? I'm just going to make sure I copy and paste this appropriately. Kimball says it took a few syncs the last time I tried. Yeah, sometimes it can take a bit. Looks like I copy and pasted it correctly. The thing is too, for the Notecard, as much as you'd like things to be instantaneous, you still are relying on a cellular network. So for a lot of projects, there is a certain amount of latency that's inherent. So Lynn says it's working. Yeah, I just got bitten by the demo gods here a little bit. I will say the one thing I love about the Notecard is it's designed to be a very resilient device. So sometimes it can be frustrating in demos because things work a little bit slow. But then in reality, when you go to try things out in a real project, for example, like if your Notecard is going through a tunnel, there's no cellular connectivity there, but the nature of the Notecard, it queues up the notes onto the device and it syncs it later on. So it is designed to be quite resilient. But it's failing for me in this project. So one thing you can try to do, if it's got it working for you, the cool thing is you can change this interval in the browser and apply it. And you should basically see that change getting pushed out to your device right away. So what I'm going to do is I'm going to try just to crank this number down so that I don't have to wait forever and push that out. And we'll see if we can test this with slightly less of a value. But I'd recommend trying this, taking this change and pushing it down as well. David says the moment the live stream ends, it'll start working. Exactly. It's not a big deal though. If it works, it works.
It happens on every live stream, every demo I ever do. It doesn't work. And then the moment I hit end broadcast, it magically starts working.
Yeah, there you go. I don't know. I might add a typo or something because I re-uploaded it again and it works just fine. So right now it's taking 15 seconds because I have this value here. We'll see if we tempt the demo gods. Let's set it to something completely irrational, like 17. And what should happen is the next time this goes through, see, yeah, the time it's instantaneous. I just had to like kick it, turn it off and on again to get that change to go through. And I've got this ability to push out these changes. And hopefully you can see where this would be useful, right? Because this is a device that could now be sitting out in some field. This firmware could be running on 1,000 devices that I have deployed throughout the country. And then I wanted to change, I divide my devices up into fleets. And I say, hey, I wonder, let me change some config on 10 of my devices and watch them for a while and see what happens. And then if I like that, I'm going to push that config out to my other 900 devices that I have running. There's a lot of cool stuff you can do with this. And I think it's a really awesome feature. And I'm going to end with Owen's question because he had asked about, and I sort of highlighted this as well, that a lot of the config that we're using here is very demo friendly. So there's specifically 3 things that are making this more of just a project that assumes you're going to push data immediately. So that's continuous mode. That's the sync flag that we have on the hub.set request. And then also this sync flag that we're using when pushing up notes. So if you do want to run this more off battery power, I would make 3 different changes to this. I'd first kill the sync on each individual notes. If you do that, instead, the notes will just start queuing up on the Notecard. And if you do that and you come up here and set your hub.set mode to periodic, which is also the default. So if you set no modes, you get periodic as well. And you have sync turned off. So true is, or false is the default. So you can have that set as well. And then additionally configure an outbound and inbound interval. So if you are in periodic mode on the note card, you have to tell the note card how often to synchronize changes, both outbound, that's data leaving the note card and going up to the cloud, and inbound. So that's things like environment variables coming from the cloud down to the note card. And these are configured in minutes. And these are the things that are really, really project specific though. So this is an example config of saying, I want to take any notes that have queued up onto the note card and push them out once an hour. So once an hour, the note card is going to fire up its modem, check any notes that it has stored on the device and push those up to the cloud. And then every 2 hours, it'll additionally check NoteHub for any environment variables, any new notes that are happening on the cloud side and push those down to the device. There's also, I should say, more advanced. There's actually a lot you can do. There's some crazy things. You can have different config for when you're on full USB power and on battery power if you're doing a project that like you plug in some of the time. So if that is you and you really want to dive deep, because we're not going to dive into cover every last thing in here, you can read this low power design guide. It's a little more lengthy discussion of all the sort of trade-offs and different ways you can configure the note card to work in those sorts of environments. But I think that's the end of this bit of the tutorial. I'm going to pause for a second to see if anybody has any questions on what we just covered. And if not, then Rob, do we want to, how are we going to cover routing? What's the attack plan here?
Yeah, so I think TJ needs a break, but for the rest of us, what I'd love to do is, since we've been covering pretty much only wireless IoT to this point, I want to, quickly transition into the cloud segment of this. And this is a very natural next step, as we get data loaded up into NoteHub. There is value there, obviously. What you've done in the first 2 hours here is you've gone from nothing to sending data from a sensor to the cloud, which is over cellular, which is a really, really significant thing. But what we want to show off is how you actually get that data from NoteHub to a way more useful place, which today is going to be Datacake. And the first thing I want to show off, and I think what I'll do is go through the sort of the very simple routing tutorial, and then we can take a break, and then I'll tackle Datacake afterwards. So let me share my screen, which I think is this one. Yes. Yep. This is going to be an all browser little mini tutorial. So it's going to be very easy for us to follow through together. So your NoteHub project probably looks something like this. So I've got data coming in every 15 seconds because my project is running right in front of me. And we can see like 1205. Yes, it's 1205. So I'm getting humidity and temperature data coming in. Mine says 31. Is it really that hot in here?
What do you got going on? Do you have like a heater on your note card?
I'm wondering about that. Yeah. It's very, very
still nothing. Still got nothing on me.
I know it will read a little bit hotter than air temperature because it's on the hardware itself.
Yeah, it's not
like properly heat shielded and such, but
yeah. I wouldn't use it for like real world data. It's really most useful, in my opinion, is like kind of a quick demo. But anyway, we've got data coming in. It's all fine and good here. Yes, there's a button here to download this data into CSV format or JSON format, whatever we do. But that's, again, only so useful. What I want to show off is the routing feature of NoteHub. So if you click on the routes option on the left, you'll see you have no routes defined. So again, a route is a way to route sync data outside of NoteHub to another endpoint. So let's go ahead and hit create a route. And the first thing we're going to do, we're going to create the simplest route, which is also still a very powerful route, but it's this first one, this general HTTP HTTPS request response route. This lets us send data out to any external HTTPS endpoint, including webhooks. You can see there's many other options here. We can send data to MQTT broker, AWS, Azure, GCP, Snowflake's in here. There's even an edge impulse route, which we're not going to talk about today, but that's a way to send data directly to the edge impulse ingestion API. It's not officially announced yet, but we are going to have a webinar at the end of August that's going to cover this route. It's going to be awesome. But yeah, more from that later. So let's keep it simple. We're going to click to create a general HTTPS request response. Now, where are we going to route this data? Go ahead and open a new tab and go to webhook.site. So webhook.site, and you will automatically be presented with a unique URL, which is just webhook.site with a GUID at the end of it. And if you copy that to your clipboard, this is where we're going to be routing data to, just as a general demonstration of what it looks like to send data from NoteHub on. Once you have that copied, go back to your NoteHub project, and I'm just going to call my route webhook, and I'm going to paste in the URL. That's it. Actually, I'm going to take one more step, and I might as well show off these filters down here. So there are ways to filter which data gets sent, either by fleets of note cards or note files. Now, if you recall, if we look at our, actually, I don't want to go back to that screen, but so far we've only been sending sensors.qo as our note file. So I'm going to limit the data that's sent to just sensors.qo. You can see I've got some other ones in here in this project, but I'm just going to choose sensors.qo. At the bottom of my screen here, there is a way to actually transform data on the fly. This is a super cool, super powerful feature of NoteHub. Primarily what we like to show off are the JSONata expressions. If you're not familiar with JSONata, it's a language that allows you to literally transform JSON on the fly. So, just to transform JSON. And I'm not going to show it off here, but we have a full tutorial on doing that as well. So just to recap, I've pasted in that URL to webhook, and I'm just selecting sensors.qo. I'm going to create that route. It's enabled, I can see here, and I'm going to head back to webhook.site. And then in the column on the left here, we will see some data showing up as soon as my note card sends the next request, which is right now. So we can see that raw content, as it says right here, the raw JSON is being sent from my project directly to webhook.site pretty much instantaneously. And we'll see more and more pop in as time goes on. Let's see. I know that took like 5 minutes, but that kind of shows off the power of NoteHub there. Granted, I'm not doing anything to the data. I'm not transforming this data in any way, shape, or form. But which actually I kind of feel like I want to show that off quick. So I'm going to deviate just for a moment to just show off the power of JSONata. And I'm going to try and do this by hand, but I'm going to head back to my route, and I'm going to create a JSONata expression, because what I want to do is really limit what shows up in here to just say like maybe just the temperature value. And I always think the easiest way to do this is use the JSONata exerciser, which is available at try.jsonata.org. And this is going to provide, so the way this works is I have my full JSON in this left column here. I've got a JSONata expression in the upper right quadrant, and in the lower right, you get the result. What I'm going to do is I'm going to grab the raw content from an event. I'm going to paste it in here. I'm going to take this function out because that's not going to apply to us. And I'm just going to do something by hand and see if I get this right. So I'm going to say, what do I want? Just the temperature. I want body.temp. So it's like a query language.
Needs a key.
Isn't it? What did I do wrong? I know.
Temp in quotes colon body.temp.
Temp quotes body.
Because you're defining a JSON object, so you need.
Oh, that's right.
That's a value. It needs a key.
Say that again. It's not a key on the body, is it? No.
I'll type it into the chat.
It's not that. So this is what I get for deviating.
There you go. It's in the chat. Although that.
Oh yeah, Doug. I'm crafting JSON. So
yeah, you're like defining your own JSON object.
Yeah. So there. So that's a simple JSON expression. What that's doing, that's just transforming literally everything I have on the right to something very specific. And then now that I know that it works here, I can take it back into my project. I can paste that expression down here, apply those changes, and head back to webhook.site. And now I guess I'll wait for the next one to come through. Any moment now, there it is. And then it's just that temperature value. So super powerful syntax. You can actually write custom functions. You can do effectively anything you want to do with JSON. But now I want to show off something far more powerful, and that's with Datacake. And maybe now's the time to take a quick break and we can regroup.
Yeah, so we'll take a break, and then we'll use Datacake to build a little dashboard of this data that we're seeing, and then we'll get into the ML stuff. So
good. So
get nice and caffeinated for the fun part.
What I'd love to do next is talk a tiny bit about Datacake. As I mentioned at the beginning, we were hoping we'd have somebody from Datacake on the call. I did hear from Simon, their CEO, that he was unable to attend at the last minute. Which is no big deal. I can do a very, very, very brief introduction to Datacake. Let me start sharing my browser again. To give you a very uninformed, high-level overview of what Datacake is, it is an IoT platform. They frame themselves as like a low-code IoT platform, which effectively means you don't necessarily need to be a developer to craft a really engaging set of visualizations for your sensor data or whatever you're pumping to the cloud. And there's a lot more to Datacake than what I'm going to show you today. There's a whole rules engine built in that gives like a Node-RED style of interface for creating different workflows. There's a white label option that lets you actually kind of skin the dashboard to match your company's logo and colors and all that. There is a really, really extensive reporting options as well. And we're going to definitely cover that to some extent, but there's just, there's a lot more you can do than even what I'm going to show. I hope by now that you've all set up an account on Datacake. And to get to that point, if you just click the dashboard, so if you go to datacake.co and click the dashboard, you'll head right to app.datacake.de. And there's a simple form to fill out there to get into Datacake. And I'll pause just for a moment in case anyone hasn't done that yet, because I think there's probably some process behind that, whether it's supplying your email and validating it. But I'll give you just a second to catch up. And while you're doing that, I'll give you another URL to hit, and I'll paste this in the chat. We're going to go through some of the routing data to cloud tutorial here to specifically route to Datacake. It looks like there's a question that have popped up in the chat as well.
Yeah, Miroslav was wondering, saying on their Mac, the ST-Link works fine over USB and can flash, but the Swan itself is not visible as a USB device. So I think don't you need the USB into the Swan itself for it to appear? That would be my first thought, but I'm not sure.
Zach alert.
Heyo. So it depends, right? Because you can turn off the COM stuff on there. But if they downloaded our Git repo and just started using that, I think we have that set, right? That's the CDC, or am I just thinking the raw stuff and that's not even an option? I'm pretty sure it is an option in Platform IO. There's the flag in the platform INI file, or whatever it's called, Platform IO INI.
Yeah, it's part of the config.
So you should be able to see it. I know that they kind of come and go on the Arduino IDE. But I don't know, we can move over to the little chat room off to the side and work on it. I mean, that's what it's there for, and no one else is in there, so it's kind of lonely. So if you want to hop in, on the, somebody splat that URL for this person, and I can pick up with them over there.
All right, resume our regular scheduled program. So hopefully you're all on this routing data to cloud tutorial. Again, this part is just going to be in the browser, which makes it very convenient. There's no programming we have to do. What we've done so far is right before the break, we actually went through this introduction and created a route. And we went through and we used webhook.site, grabbed that URL, created a new NodeHub route. We pasted the URL in there and just started pumping all of our data over to webhook.site, and which is literally what we did here. I did have some stumbles around using JSONata to transform JSON. This is effectively what is going on in the tutorial here as well. So this is a good example too. It shows off kind of like I showed the really quick 101 to get the temperature data in there, but it shows you a couple of things you can do. You can actually concatenate values together here with ampersand. And so you can get one location field from two different fields that come from the JSON. So a lot you can do with JSONata. And then we get to routing to an external service. So again, today we're going to focus on Datacake. We do have tutorials for the AWS's, the Azures, Google Cloud, UbiDots, Saphira, UbiDots, Fan. I think there's Snowflake. There's a bunch of other ones in here as well. But again, we're going to focus on Datacake. And what we've done so far, hopefully you've created your free Datacake account. And now we are going to go ahead and create a device in Datacake. So a device is what it says. It's a literal hardware device, which in our case is a Notecard. So in my Datacake dashboard, which you'll see is kind of polluted with a bunch of other devices because this is our kind of our company demo account, I'm going to hit the add device button here, and I'm going to choose the API, so the generic API device. Click next. I'm going to create a new product from template. And the template I'm going to choose is, well, the Blues Wireless Note Card. And FYI, if you see Blues Wireless around, we recently changed our company name from Blues Wireless to just Blues. So, whoop, that just changed automatically. That was weird. So what does that mean for you? Nothing, just so you know, Blues Wireless, same thing. And I'm going to click next. And now we need to provide a device name. And in our case, I'm actually going to supply the serial number for the device. So if I go back to my NodeHub project, which as a quick aside, I went ahead and disabled my webhook route. You can delete it or disable it. It's just probably best not to keep sending data to webhook.site because they will shut you down after like 500 events. And I'm going to head to my devices tab. And I'm just going to click on here to copy in that device ID. So just from the devices tab, head back to Datacake, and I'm going to paste in the serial number from my device. And in this case, I'm just going to call it Rob's note card. How about that? So serial number, which is the unique device ID, name some arbitrary string. Click next. And I think before we restarted, I think we dodged a bullet because there was a very short maintenance window for Datacake, and I was kind of panicking for a second. This is actually making me panic a little bit that it's not popping up right away.
I saw that as well and thought I was going crazy.
Yeah.
Because my session had gotten logged out. So I don't know what they're up to over there.
Well, it is Friday evening. I mean, that's a logical time.
It's there. Yeah, it is definitely their maintenance window time. That is fair. In fact, let me refresh mine. Let me see if mine is still running.
Yeah, I'm going to set mine up too. If necessary, I could take it over if it's just you. But
let's see.
Got a message from Mark that they're in. I wonder if they're still pushing something out because there you go.
Mine just
You're
came
in now.
through.
I think because mine was slowed down for a second there too, and it just loaded.
So for the plan, you can certainly start paying them if you want, but what we're going to do today, just choose the free plan. And I should mention too, that Datacake has a pretty generous free tier. You can actually add 5 devices for free. So add 1 device. And I assure you, it's normally much faster than this. So device has been added.
Yeah.
And
Mine's
wait for
going
this to
really slow
reload.
too.
And I'm going to head back to our tutorial here to make sure I haven't missed any steps. So we chose the product template of the Blues Wireless note card. We copied our device UID, pasted that into the serial number field. We chose the free plan. And now we're going to head to the device view. So where there's Rob's note card. So I'm going to click on my device name. Yeah, I think it's just running a little slow. Oh, it's not too bad. The first place I'm going to go in Rob's note card is to the configuration tab. This is the most important tab when you're talking about Datacake. This is where all the power is provided. And the first thing we're going to do is configure the fields that we're sending. So in our case, we're gathering temperature and humidity data. So we want to make sure that Datacake is aware that this data is coming in. This is going to get slightly confusing, but for a good reason. So Datacake actually, in the template that you've provided, or the template that we used, they provide I'm going to skip over a lot here. Oops, this is what I wanted to show. They provide a preloaded payload decoder. So what this does is this is just a JavaScript function that's going to ingest data from our whatever data we're sending. And they have some pre-configured JavaScript that is going to actually look for, well, what do you know, sensors.qo, that's the data we're sending. And that's going to pull in the temperature and humidity data. So they've done the dirty work for us. I want to come back and look at this in a little bit more detail. But first, I want everyone to scroll all the way down to the fields section. And again, you're going to get a lot of boilerplate in here. These are a lot of values that come through by default with the note cards and some of the metadata that comes through. And we're going to see that we have temperature and humidity already configured. The one trick, though, is that I think in our project, I'm going to go back to my events view, that we call temperature temp. Yeah, so we have humidity is spelled up, but temperature is temp. Here, it's temperature. So what you can do is go ahead and click on here and say edit field for the temperature field. Oh, no, I take that back. You can't do this because the temperature values the identifiers are set and you can't change them. So we're going to go ahead and just add a field. And I'm going to call it temp, which will give us the temp identifier. The type is going to remain float. And we can just add that field, which, another short delay. But I love how they have all these other fields pre-configured, like the tower location, to let us kind of start using some of the other widgets immediately.
Yeah, you'll see here in a second when we configure the route that the cool thing about Datacake having a template for working with the note card is not only are all those fields there, but you can also start using them in the sort of dashboards you're building and creating as well.
So you can see now we have temp and humidity fields that are defined. So that means Datacake knows we're going to be sending some values through that are called temp and humidity. It's that simple. And so that's what we've done so far, created those values. So with those fields in place, we can now configure the payload decoder. You don't necessarily have to follow these instructions because of the existing template. So I'm not going to literally go through every step here. Instead, let's go ahead and scroll way back up to our payload decoder and kind of walk through the code that they've already supplied. The first line is probably the most important. We've got a data variable that's parsing out the body of the request. Now, if you remember what the body of the request is, it is literally just this. So it's just humidity and temperature values. So when those are the two values that are going to be available in this data object. All right. So I take it back. It's actually, the body here is the full request. So it's going to give me the full, if I open up the JSON here, it's going to give me access to this full JSON object. So if I look at then the file, so the file variable is going to be data.file, which if I go back here, I'm not going to do this for all of the fields, but you can see data.file is sensors.qo, the name of the note file. And then it says, well, if the file is here, sensors.qo, what I showed you earlier, we can specify the temperature and humidity values to be data.body.temp, which again, if we traverse the JavaScript, data.body.temp, you can see how those apply here to our JavaScript. So this payload decoder is saying, here's this big chunk of JSON. Let's, condense it down into only the values that we need. This is effectively replacing the JSONata expression. So we can do a lot of this in JSONata as well. Datacake provides a nice UI to do it in JavaScript instead of JSONata. And that's about it. The rest here, it is going through and getting a location based on the tower data, the tower location that TJ showed off earlier. And there are some other values in here, like the RSSI and bars. Those come from the wireless signal. That's not being sent over in these notes that we're sending, so we don't have access to that data. Now, now we want to go ahead and create a route. So we can head back to, actually before that, we need to copy this endpoint URL, conveniently located right underneath the payload decoder. So if you just copy that endpoint URL, we can head back to the NodeHub project and go to routes, create a route. Again, we can use the general HTTPS request response route. I just wanted to let you know there is a new, way down here, a new Datacake route. Right now, it's kind of, I consider it more in beta mode because there's not anything specific about this route that makes what I'm going to show you any easier. So you can use that if you want. I'm just going to use the general HTTPS request response route. I'm going to call my route Datacake. I'm going to paste in that URL. And in this case, I'm going to do the same thing I did with the webhook route. And I'm just going to choose sensors.qo to be sent over. And with that, I'm going to create the route. Again, very, very simple on the NodeHub side. What did I miss? That's exactly what we need to do. Okay, so now we need to wait for a moment as data comes in, and I'm going to head back to the dashboard of Datacake, and we should see some, actually, if we go in, if you click this little toggle here, you can start editing your dashboard, and we should see, I want to make sure that my data is being routed correctly. Here's another handy feature of NodeHub. You can actually check the status of the route. So I've got data being routed out here. This says the route was successful. If I double click on an event, you can actually look at the route log. So this said it went to Datacake successfully. And sure enough, so I've got temperature data showing up there, 32. What the heck's going on here? I'm not that hot. Humidity is here as well. And we see that our the tower location shows up in the map widget as well. Another reason why I love Datacake, they provide this nice clean dashboard as part of the template, just kind of works out of the box. So the rest of this is going to show off some of the additional widgets that are provided in Datacake. So the default dashboard, as you already saw, shows temperature and humidity in a single, like a circular chart. I can't remember the name of that widget. We're going to go ahead and add another widget. So let's go ahead and customize our widget a little bit by adding a widget. And again, I'm going to deviate from the instructions here because we already have a map widget. I'm gonna first maybe delete some of these, and I'm going to add a widget that is a chart. And my chart is going to be, why don't we say temp and humidity. My data is going to be adding a field, and my field is going to be temp. And we're going to show temp. We'll keep it an area chart. We can change the color. We'll do red because it's hot apparently. I'm going to add another field. That'll be humidity. Keep the default label of humidity. That area chart is going to be, how about green? And I'm going to save those. Actually, first, I'm going to click on the appearance, and So I think that's fine. Time frame. Let's switch the time frame to hour. We'll get better values coming through there, I believe. And so this is just off the top of my head. I think I did everything right, and we can drag this around and resize it a little bit. I love how smooth their UI works. And one thing you need to remember with Datacake is to save, you need to kind of hit this toggle. So that's been saved. Now what we should see coming through is a more historical view of our temperature and humidity values. And if it's not, I'll be confused. Unless
You
TJ,
did have one reading go. You did have one reading go through. I think you just need, since it's an hour time frame, it's going to be a while before.
Yeah, I guess we might not
see much. Because see, I think if you scrolled over the middle of that, I think there was somewhere in there is some data, but it's going to look
there
weird
it is.
until
It's one. Yeah, I'm probably sending it at too frequent of a cadence. Out of curiosity, you can do custom. So 5 minutes. Kind of afraid to do this, but
you can do it from 5 minutes ago to 5 minutes ago to now. Resolution 1 minute, something like that should work.
Type it out like that. Time zone.
Change the resolution though to like every minute, or
I love it.
Well, maybe like
well. Oh, we're getting data in there, but my
press save. Right?
See, this is why I need somebody from Datacake here, but the values are definitely coming through, or at least the humidity is.
It's fun to play with. The other thing I'll say too is that the one thing I love about using Datacake is they have this. Rob, can you hover over the public link button when you're in edit mode? So you just got to put edit mode back in for it to pop up. I like it because it's an amazing platform to use if you just want to quickly show something off to your friends or your boss or something like that. So like I've got data flowing in. I can set up this device for totally free on Datacake. I can really easily build a dashboard for doing it. And then I have a link that I can share with people to show off how it works. It's pretty cool.
Yeah, it's great. And in our tutorial, we do cover, just to kind of assure you that this does work, seeing these visualizations here. They're really quite gorgeous out of the.
It's also way easier once you've built up like a data set. So then you can see with it rendered with like an hour's worth of data and such. It's far easier to play with these and tinker with it. Yeah. So if you want to just leave the data flowing in yourself and just play with it later, it's a lot of fun.
Yep, it's a great point. So that's really what we wanted to show on the cloud side. Just again, like that thread of simplicity. We have cellular data being sent over the wire to NoteHub and then routed onto Datacake with really, quite literally no programming required. And even if you do need to do some programming, their payload decoder is pretty intuitive. And I love how you can set up all those fields and configure your dashboard as needed. So what we want to do now is like kind of quickly keep moving on here. I know we're almost 3 hours into this and get to the machine learning part, which is honestly the most fun part of all of this. Owen, do you or David want to do a little intro to Edge Impulse now?
Yeah, I can do the couple of slides that I have here. Let me just see. So I hope you can hear me okay there.
Sounds good.
Yeah. Audio sounds good.
All right, cool.
Yeah, there you are.
Here I am. Let me just see. So yeah, I've got a couple of slides here. I'll keep it light enough and kind of I've tried to make them a bit more relevant as well. So here we go, this one. We're doing slideshow. So let me know if you can you see the slideshow now?
Not yet. Not for me, anyways.
Okay. I'm just going to change this slightly. Have one. Here we go. Yeah. You should see it now.
Now it's
Yeah.
coming. Yep, there it is.
Okay, so I just want to give you a quick intro to Edge AI and Edge Impulse. I'm Owen and also joined by Dave, and we're both from developer relations. We're working in Edge Impulse, and we're just going to talk you through this right now. And then at the end, Dave is going to give you a quick demo. So we just want to give a quick overview of Edge AI and why is there all the hype about AI at the moment, and why do we care about it in IoT? And I'm missing some content from this slide, but basically it's just a lot of hype at the moment, as everybody's aware, about AI. And
Hey, where'd all the other pictures go?
I don't know where all the
Well,
rest.
only-
Oh,
wait.
here we go. Here we
Here
go.
they come.
Here it comes. Okay, there we go.
Hey,
All right.
all right.
So yeah, this is the hype about AI in the media at the moment. And why do we care about that in IoT? So I guess Rob kind of alluded to this at the start, and some of these problems with IoT that they've solved in Blues Wireless around privacy and security, power, bandwidth and latency, reliability. Some of these concerns can be addressed by implementing your learning or applying your model and you're at the edge of the network. So you're only transmitting smaller portions of data. So you're less likely to be concerned about your privacy. Less amounts of power is being used. It's going to be less of a cost if there's a cost associated with your transmission of data and your network. Reliability as well, if we've got any connectivity problems, and bandwidth and latency. So it's kind of a paradigm shift from traditional rule-based programming, where rather than trying to build rules for the types of sensor input that we get, and let's say, like, if we wanted to do something like building a threshold that would trigger an alert from a rule, we could do that rule-based. But if we know the outcome that we're trying to predict is dependent on the sensor input, then we can build what we call a model and boil that down to the algorithm and deploy that to a device. So once that input has been detected again, we can, with a certain amount of confidence, we can apply a label or classify that. So let's say we can group the data. You can see there's clumps of data that are grouped here. These could be different types of scenarios that were encountered with a accelerometer. So machine learning is broadly broken into three categories. So there's supervised, unsupervised, and reinforcement learning. And today we're going to be mainly looking at supervised, and within that classification. So we're going to try to classify types of movements. So what we design at Edge Impulse is known as an impulse because it involves more than just a machine learning model. We also apply digital signal processing to extract features from our input signals and use those features to feed to our network, which we train at the edge, which we train on the cloud and then deploy to the edge, where this neural network can then be utilized to give a confidence. Let's say we can see here on the right, we've got a confidence score of 0.91. So we can do something with that confidence score. We can use that to build our logic. So we can perform this type of edge intelligence with any sensor, any data, in any use case, and within certain parameters. So for the lower power devices, the smaller types of devices, we can do single sensor classification or anomaly detection. And then as you want to scale up or you want to build more complicated solutions that involve image or complex voice, then you can, let's say, decide on the types of hardware that you might want to use. So we were powering a large edge ecosystem with MLOps. We've got a large amount of developers. I think we're at a lot larger of a number than 80,000 at the moment. We've got 185,000 plus projects, and we're working with a number of enterprises as well. 5,000 is listed here. And the reason I'm mentioning enterprises is here, I know there's a developer webinar, and within the developer space, you're free to use Edge Impulse for your projects, and you probably won't hit the limits that involve enterprise account. But I just wanted to put this there as well, just in case if you are hitting limitations, then that's possibly a good thing, and you're starting to move to a place where you might want to use this in a product that's going to the market, and then we can all celebrate with you. So where can you use Edge ML and Edge AI? The reason I just put this slide here as well is because some of these ones that use accelerometer, and specifically accelerometer and tracking, let's say, will be supply chain optimization, predictive maintenance. The accelerometer that we're working with today, you could have mounted to a motor, and that can oscillate or vibrate at certain conditions if it's starting to break down, and you can try to predict that outcome, and you could communicate that back to your Datacake dashboard. So I'll just give a quick run through of our product as well. What is Edge Impulse, and what's the UI that you're going to be using today? So to develop Edge ML applications traditionally, as with developing IoT applications traditionally, can be a complex problem to solve. You have to build out your own solution for collecting, designing, testing, deploying, and anybody who's familiar with embedded devices will know that deploying is a complex problem to solve in itself. So we've got a platform which is called Edge Impulse, and the studio is the UI part that you're going to be using today, that enables you to collect, design, test, and deploy to any edge device. And this is a quick overview of our architecture. And we've got a number of, I think the most important things to look at here will be we've got a couple of AutoML steps here, which is the Eon Tuner, which will help you to tune your model. And along the way of designing your model, we're going to give you a lot of tips and tricks, and you'll see stars and suggestions for how to build your model. And the tuner will help you to fine tune it to select parameters for you. And the compiler then will help you when you get to deployment to save some space on your device. So now we're going to get to the UI. And here we're going to try to collect some sensor data from the accelerometer, and you can see the output from the accelerometer on the right here, the XYZ axis that we're going to collect. And then we're going to apply a label to each sample of that data. You can see the sample length here is 10 seconds, 5 seconds. We can select the amount of data that we want to collect from the sensor at any time, and apply a label. Then if we're doing the up-down movement, we can record it and we can apply our label. So this is the collection, and yeah, I spoke about this part already, so I'm just going to skip it. Actually, one point to note here as well is that actually while we're collecting, we can define the train test split. So this is kind of important because we want to reserve a portion of our data that we collect to test the model at the very end that will never be touched in the development of the model. And that's very important for validation. So this is the kind of the core of the Studio Edge Impulse. And this is where we build our impulse, which is not only our model, which we can see on the right in our learn block, but also the digital signal processing blocks, which we call a processing block. And you can see here the spectral analysis that we can perform, which is going to extract features from our accelerometer data And these features then will be fed onto our neural network to improve the performance of our model. And in fact, it's needed as well to be when we're working with time series data to extract this data in a tabular form that we can feed on. So when we're building this, as I said already, there's going to be stars next to each of these portions that will help you to configure this. And then we can test, once our model has been built, we can, because we've got our firmware loaded on our device, we can, and our firmware involves drivers that connect to each of the sensors that are on the Swan or any of the devices that we've deployed our firmware to. We can connect back to the studio, and we can see how our model is performing on the device. So then we can deploy. Once we're happy with our model, we can deploy to the device, and we've got specific firmware for the Swan that we can build our model and deploy to, and that will just download a script which we run, and it will flash the firmware directly onto the Swan. And I don't know if there's any questions about this now, but Dave is going to give us a quick live demo.
Might give us a live demo.
Okay.
Well, we're gonna see.
Yeah.
While you were speaking, I was trying to do a quick run through, and of course it's not working, even though it worked all day yesterday when I tested and built it, and it even worked this morning a few hours ago.
Okay.
But we'll see now. So I think TJ may have done us in. Yeah, jinxed
everything.
Us. Yeah. So, all right. So let's see if I can bring up a screen share as well. And what we want here is going to be a couple of things, actually. So I'll switch. First, we'll hop into the studio. Let's see if this comes up. Now, I've lost my ability to see you all. So hopefully you can see my screen. Do you see Superhero Showdown?
Yes.
All right.
I'm excited.
Yeah. Well, can you also see me or no? Am I gone now?
We see you. You're good.
All right. Perfect. So at least that's working. So as Owen was kind of alluding to in the slides, here is the Edge Impulse dashboard. And I've built a project. Now, Owen was showing sensor-driven data, and TJ and Rob were mostly showing sensor-driven data. I'm going to go one step further and do a computer vision use case here, but there's some good talking points as to why this is also important. So my Superhero Showdown project, I have collected 1,001 pictures of this guy, Superman. Actually, I take that back. I've collected 500 pictures of Superman and 500 pictures of Batman. So, and I don't know where the extra one came from. Somebody got an extra click, I guess. But suffice to say, that took a long time, and it was worth it in the end, though, because I came away with a really good data set. So when you're building a data set, you want to have variety in, obviously, the images that you want to collect, but things like lighting, background, angle, any other, if you can rotate the object a bit, that's helpful. So here's a little bit closer. You zoom in, you zoom out, but you can see what I've done here is taken, like I said, various pictures, 1,000 of them, of these, what would you call these things? Toys, I guess? I don't know. Of these superheroes.
Action figures?
Action
maybe?
figures. Yeah, action figures. That's a good word for it. And you can see how I've sort of varied. I took them all around the house, grabbing pictures of them. Let's find one. Where's Batman? Where's he hiding? I have 68 pages of data here. So here we go. Let's see what that one looks like. Oh, yeah, there he is. So all said and done, I got 1,000 pictures. And as Owen mentioned, training and testing is also very important. So I only train on 80%, 800 of my images. But what I've then done is come through and created an impulse. This is your model that you're going to deploy. And I'm using an image classification block for ultimately an object detection model. And I came away with a 97% accuracy, which is pretty good, actually. So my model, after I ran it through training, looks like it was 94% accurate on Batman with 5% error rate, but Superman was a full 100%. So that's pretty decent. Now, your real world conditions will, of course, vary. If I take these action figures and place them into a background that I did not account for, lighting conditions that I did not account for, or quite honestly, I put Spider-Man in here, this model is not going to know who Spider-Man is. But this is still a good demonstration. So at the end of this process, you can go through the build and you can choose what type of hardware you're going to deploy on. Now, I think perhaps I am a little bit small in the view, but you may have seen me hold this up earlier. I've got a Raspberry Pi in front of me, and sitting on top of this Raspberry Pi is the Blues Notecard. I have it on the Pi hat, and I've also got hooked up a USB webcam. So what I should be able to do, I'm going to have to switch my screen share out from here. Actually, you know what I can do? Let's see. Stop share. Share screen. Let's do the entire desktop. Hopefully okay. Hopefully this is still visible. I want to keep the browser here for just a moment, but I also want you to see that I have my Pi's HDMI output fed into a USB capture card. So it's literally being rendered here on my Mac desktop as well. Can you see that? TJ, are you able to see a terminal? Okay.
That's slick too. I haven't thought of relaying the Pi over that way. It's
kind
of neat.
It was great. It was only like $10 or $15 on Amazon. I couldn't tell you the brand name, but it's just a USB dongle that takes an HDMI input and creates a camera device out of it. In this particular case, I'm using it as a just as a QuickTime input, so I can keep kind of both running. But so over here in the Pi, now I have a different keyboard and mouse hooked up, so it's a little bit wonky. But I threw together, with some help from the team, a little Python application. I am not a Python developer, but I was able to make it work. That essentially, let's see what I'm doing here, importing Notecard and then telling it where the Notecard is located, which is I2C-1. This is all out of the box using the Pi hat for the Notecard. And I'm appending into the sensors.qo note a string name and confidence. And the string name and confidence are the name of the superhero and the value that I'll show you in just a moment, the essentially percent confident that the model is that it is looking at Batman or Superman or any object that you train your model on. And then we send that up to Datacake, and we'll be able to render that in their dashboard, like Rob was showing you the dashboard earlier as well. So the very first thing I want to do before I fire it off to Datacake, though, is just show you sort of what this output will look like. So I'm going to use the Edge Impulse Linux runner, and I've got Okay, so the camera is working. I can now come over here, reload. I will have a feed that is staring at my door, but let's get Superman in front of it.
Yeah.
And we can see that he's being detected. Okay, so we've proven step one. Let's set that back down. Which mouse is this? And stop that real quick. I wonder if I scrolled off. Nope, there we go. So there was the raw data that was coming from the impulse itself. And it always follows this format. So my Python snippet then parses this and extracts out the label, and we can see value 0.7254, 0.6958. So that's the confidence that it believes that that was in fact Superman. So let's now run the Python, which will take this a step further and send the data up to Datacake. Okay, you can see in the background, oh, he's a little blurry. But we are, if I hold him up a bit higher, see if we can get, yeah, we can see him back there. Okay, so now, moment of truth. I have some bad JSON in here somewhere still. Moment of truth. If what I think should have happened is via my Datacake route, I should have sent that to this endpoint, which I have in this tab here. And sure enough, were you able to see that just flip from Batman to Superman?
Just came in. Yeah.
Yeah. And so the last, I guess the last one before we exited out was 67% confident that it was Superman. Now, okay, plenty of stuff just went on, but let me break down why that's actually important. On the Raspberry Pi, I had raw video being captured. Now, that by itself is a bandwidth intensive process. I don't actually want to send the raw images over the Notecard unless I really, really need to. If there is some anomaly that's been detected or some use case for maybe a screenshot, one frame out of the video, then okay, fine. But generally speaking, from an IoT perspective, I kind of only care about what was detected, just the fact that it was Superman and 67% threshold. If I come over here in Datacake into the configuration, I can actually show the payload that came through. So all I sent across the Notecard was this. Just the text, just the JSON, I don't know, what would you call it? JSON, the raw, the blob, the payload. So in that manner, I can minimize my data usage. And I had this demo running. I mean, you saw it. It was pretty much a live stream nonstop. You could, in your Python, set it onto specific delays, run it, sleep 10 seconds, sleep 10 minutes if you're just monitoring some, slow moving data like temperature. But the point here is that I was able to build a machine learning model through Edge Impulse. I was able to then parse out the raw output of that model as it's running on the device, on the Edge device. It's running on a Raspberry Pi. It could run on the Swan. It could run on any number of supported devices. And send for visualization, although Rob's dashboard looked a lot prettier than mine, I have to admit. He's better at building Datacake dashboards than I am. But send the results, the inference results, the machine learning output across the Blues cellular connectivity and pipe that into Datacake, or you can use other platforms as well. But, like we kind of showed off, the Datacake system it's easy, it's point click. I made that dashboard. Granted, it was not a nice dashboard, but it only took me 5 minutes. So it's pretty interesting way to do, like we've talked about for, I guess, 3+ hours now, machine learning on the edge over cellular. We proved it. We did it. And I don't know, Rob or TJ, if we've got more to cover here, or Owen, actually, if you have more slides, I think we may have come away about 45 minutes ahead of schedule.
No, because we want to do this ourselves. We have a whole tutorial to walk through.
Oh, I just spoiled the whole thing. I didn't know that.
No, that was a great introduction, because that will provide much more context around what I want to walk people through. That was great. Thank you very much.
I'll stop talking then.
I love that demo too, because it brings everything together. And to even build on what you showed, like, not only sometimes you only care about the results of the inferencing, but sometimes all you care about is when something's not right. So like maybe that's monitoring a machine, and for the most part, you don't care about the data that's coming out of that, because it's just going to be a bunch of noise. But hey, if you detect an anomaly, if you think something's wrong with the machine, then you might want to use the Notecard to send that up, and you might want to use our routing to send that to like Twilio or some sort of alerting system that you have in place, so that it texts somebody, so that you can immediately look into it. And I think the fact that it's possible and that you can run that stuff on just like something like the Pi or the Swan is like, it's just something that still amazes me. I'm a tech person. I still find it crazy that you can run that on these tiny little things. It's very cool.
Yeah. No, I mean, it wasn't that many years ago you needed to do inferencing on a PC's GPU. Like, So yeah, I like that demo. Okay, fine. It's an action figure. It's Batman or Superman, but it's visual and it allows to understand the concept, because then what you explained, okay, great. I took a picture of Superman. Who really cares? But in the real world, exactly like you just described, then machine health, anomaly detection, only send what is important. And if it's something that, a value is out of bounds, trigger an alert, exactly like you described. So, all right. Well, I guess, Rob, do you want to take it away? Or Owen, were there other slides you had left?
I had 2 more. I'll just give them quickly, because just tying the end up here and tying it back to the Swan very quickly. So I just wanted to say as well, here we go. So after the demo, I was talking about this use case. So we spoke a little bit about predictive maintenance, and there's some interesting ones on asset tracking as well, which the Swan would be perfect for. And I've just I've built a case here for it's just kind of a general case, but it can fit the Swan. So you can put the Swan inside here, and it fits with a battery as well. And there's some space here on the back for some magnets, so you can stick it onto something. And you can download that from Thingiverse if you want to, and print it, and you can try and build some stuff. Just wanted to say thanks as well for listening to us, and hopefully we can continue on with the demo. Stop this now.
Awesome.
Yeah. Thanks, Owen.
Cool.
Yeah. So, all right. So everybody saw an overview of what we're going to cover. I'm going to start sharing my screen, and I apologize because you're about to feel the full wrath of my monitor here in a second.
I can't wait.
Share my
excited.
desktop.
Rob's got a 87-inch.
Is this bad? How bad is this?
Hold on. You know what? Let me.
I think the badness is how wide the people viewing this, how wide their devices are. Because if they also have a television that they're viewing this on, it's going to look totally fine. For me, it looks average. Like I can still see it. I guess. Kimball says it's fine on my 32-inch wide. Yeah. Mark says it looks great.
So the first thing I want to do is actually go back to Datacake, because the fact that I went off script led to some problems here. And I just want to tell you what I did wrong, just so you know. So in the payload decoder, remember how I'm like, oh, hey, the decoded temperature is right here. I didn't realize that I was referencing temperature, right? But you remember I created a field that was just called temp. And then the decoded temp came from the wrong place, data.temp instead of data.body.temp. So actually I wasn't pulling in temperature correctly. My fault on that one. In my dashboard, which, well, this is going to look horrible now. Oh, goodness. Now it doesn't even look that good. Anyway, what I did wrong there was I didn't create two separate axes for the temperature and humidity data, if that makes sense. So they were both, well, the temperature data wasn't even coming through, and then they were both on the same axes anyway, which would have made it look all weird. Anyway, the tutorial is correct. Don't listen to me, listen to the tutorial. Now, what we're going to do is actually, we're going to go through a very similar exercise to what David just showed you, but this time we're going to use the accelerometer that you all have, so the LIS3DH. And what we're going to do is follow this guide here, and I will copy this into chat. Holy smokes, here it is. That's the link we'll be using. And okay, this is a big one. I'm going to warn you, there's a lot of steps here because we're going to actually write a new set of firmware for our device. We're going to be using the terminal here a little bit. We're going to be using Edge Impulse Studio as well. And then we're going to follow the instructions a little more closely than I did for the Datacake one. I want to start with the setup section here. We're going to, again, use Platform IO for programming the Swan. So you already have that set up. You've gone through the quick start. You know that works. You're going to need to set up, and hopefully you've already done this, set up a new account with Edge Impulse Studio. So if you go to studio.edgeimpulse.com, you'll go through the quick sign up process there. And you're going to need to have the Edge Impulse CLI installed, which again, hopefully you've gone through that process as well, because I'm not going to take time to go through that because that can be a little bit tedious, only because it's an NPM install and there's some dependencies that have to be installed. But if you click on the link provided, it'll take you to the page and walk you through that process very smoothly. So let's start with Edge Impulse Studio, and I'm going to go ahead and just ignore all the projects I have here. I'm just going to create a new project, and it's going to be, I'm going to call it TinyML Awesomeness with Rob, because that's what this is. And I'm going to create that new project, and I'm going to leave that the way it is. I just want to make sure that project is created in Studio. And I'm going to head back to my tutorial, and we're going to skip the Arduino IDE instructions. And instead, we're going to go to Platform IO. And it's saying if you're using Platform IO, we're going to have to add a reference to this library. But we need to create a new project, right? So you can create a new Platform IO project. I'm going to create a new one. It's going to be called
it's going to be called TinyML Awesomeness with Rob.
I'm just going to call it this, my awesome ML project. Same drill as before. We're going to choose the Blues Wireless Swan R5 and keep the other defaults. And that's going to take just a second here. And remember, since we're using Platform IO, we can simply copy and paste this into our Platform IO INI file. And I'm reminded now that I actually need my...
Got to grab the default Swan config again.
So what I'm going to do is open up my Swan project. So this is the one that you already created. I don't need all of these dependencies because we're not going to get into the Notecard stuff here, but I'm going to grab this section if that's clear. And
you can also grab it again from the Swan quick start.
Yep, that
and
works as well.
I'll paste in a link.
Thank you.
To the chat where you can grab it from there as well. And it doesn't hurt to have the extra libraries. We won't be using the Notecard to start.
Yeah, and I should qualify this. You can actually reuse the existing project that you already set up for Swan. There's nothing super unique to this. I'm just starting this from scratch. So your platformio.ini file should look something like this. So we're ready to start programming, but we're going to actually go back to Edge Impulse, because the first step with any ML project is to build and start training a model. So what we're going to do is use the accelerometer, which I didn't mention. You should actually plug in. I can't actually share my desktop as well as TJ can, but it should be pretty obvious that quick cable plugs into the accelerometer. TJ will kind of hold it up there.
I'll hold it up. Yeah.
You can plug it into one of the quick ports. They're called on the
quick ports on the no carrier F, and it slides in. Oh God. It only slides in one way. So if it's like a USB-A, right? It's annoying. You'll probably get it wrong, and then you have to flip it over and do it again. There's 2 ports on the F. It doesn't matter which one you pick. Either one of them will work.
So what we're going to build is called a gesture recognition model. So we are going to move that accelerometer in a few different ways. As it says in the tutorial, there's an idle, which is no motion, a chop, which you can call like up, down, or whatever you want to call, and then a wave, which can be left, right, or whatever you want to do. We're going to provide 3 really distinct motions. But the first step is actually to make sure that the XYZ, the accelerometer data is coming through correctly over serial. So we've got a very simple sketch here that's just going to read data as efficiently as possible off of the accelerometer. So I'm just going to copy this sketch. I'm going to open up my main.cpp file, Control, Command all, and paste it all in. So what this is doing, it's just, it's initializing serial, setting up my accelerometer, and it's literally just pumping out the XYZ values as quickly as possible. And when that is ready, and I know I'm moving a little bit quickly, so just pause if anybody needs help here. I'm going to go ahead and upload this to my Swan. And as soon as
also paste a link while we're waiting for this to compile to this tutorial we're going through. So if you do get stuck on any bit, you can always go through this at your own pace later on. All these instructions are online.
I'm going to head over to my serial monitor, and I'm going to pick, I think that's the right one, start monitoring. Okay, so hopefully at some point soon you will see something like this. What is being provided to me over the wire now are the X, Y, and Z positions of my accelerometer on my desk. If you kind of blur your eyes, you'll see as I start to move this, you see the values change, especially the Z value as I flip it over. So as I move it around, you can kind of roughly see that those values are changing over time. This is a very good sign. It means my accelerometer is working and it's piping data through to my Swan, and my Swan is sending it to me over serial. So far, so good. Now what we're going to do is actually we're going to run the Edge Impulse data forwarder. So this is going to be run in our terminal window. And actually, before you get into that, make sure you stop any serial monitoring, because we can only have one process at a time accessing that data that's coming through. So I'm going to run Edge Impulse data forwarder, because we want to be able to start sending this data to Edge Impulse. This is a super cool utility here. And, oh, that's fun. Let's see. What did I do wrong here? Oh, this was an error I ran into the other day. So,
is that on our side? Where is that?
So yeah, so it has to do with the version of Node I have installed. I thought I had resolved this. Let's see. So I'm on 17.9.1. This version of Node requires Node module version. Okay, here's what I went through. Let's get a Node module. Let's see. 102, that is 17.9.1. Well, this is interesting. This just worked for me.
Is that because, let me see.
Let's see.
Binding stuff. JS.
Oh, I can't even look at the version.
Yeah, it's down to
Let's try this.
V17.9.
Let's make sure I'm on the latest version of the CLI.
Yeah.
What should happen too is once what the data forwarder is going to do, if it is working for you, it'll start prompting you for information about your project, because essentially you're setting up a connection where the data you're collecting off the accelerometer can basically funnel into Edge Impulse, so you can start building up your model. Because kind of what David showed, where you had 1,000 pictures of Superman, you're going to start to need to collect data, because we're training this thing to recognize chops and waves and everything, but you need data flowing in to train a model to do that. And that's what's setting this up. And it looks like it worked, Rob.
Yeah, so I think I don't know what I did. Just had an older version installed. So what your first prompt is probably going to be to log in. I've already authenticated. I just did this yesterday. So it's already asking me to choose which device I want to connect to. So it's looking over serial and saying that there's these two devices. In my case, I want to connect to the one with the longer string. I know that's my Swan. This one is probably the Notecard, because that has an ST chip on it as well. And when I hit that, we are going to... Oh, you know what? It automatically connected to the project I was using yesterday. So I'm actually going to kill this. What is the flag for resetting? Is it like -- reset?
-- clean. It will give you a new connection.
And I'll have to like log in again.
You have to log in again, yeah.
You have to log in again. You can also use, there's an API key that you can grab from your project, and you can just pass that to log in rather than your password if you want to.
Oh.
So you get that from keys. It's just the tab directly beside project info.
Okay, perfect. So I'm going to go through that again, choose the device, and I'll choose a project. So what did the project I just created? TinyML awesomeness with Rob.
Rob's a Edge Impulse enthusiast. He's got a huge project list.
So hopefully you're seeing this as well. So the Edge Impulse data forwarder detected this data coming over serial, 3 sensor axes detected. I'm going to call them X, Y, Z to identify the 3 different axes. And the name I want to give the device, I'll just call it Swan. You can leave it as the default as well. So it says device Swan is now connected to my project here in Studio. And I'm going to grab this URL to start building my model out. Okay. And let me double check. I didn't miss a step over here, did I? No, that's right where we're at. Okay. So I'm going to start collecting some data, and I'm going to navigate to the collect data tile, if you will, here. And want to make sure that my device shows up here, which it does. We're going to use the default 10,000 millisecond sample length. And the label I'm going to give it is the first of 3 actions that I want to capture. Now, this is where I'm going to do this relatively quickly, so my model is not going to be perfect. The more data you collect, as David kind of showed off, the more data you collect, the better your model is going to be in general. So I'm going to call this first one idle. And before you start sampling data, if you think about how an accelerometer works, it not only matters the location, but also the orientation, if you think about that. So an idle accelerometer that's facing straight forward is going to be different from an idle accelerometer that's facing to the left or to the right or upside down. So I'm going to make sure when it's idle, it's literally like facing away from me, just to make sure that I get some really accurate data. So what do I do now? I hit the start sampling. To me, this is freaking magic, frankly, because I'm doing something from a cloud service that's interacting with my terminal here on my local machine. So it's gathering that data. I've got a 10-second idle sample. Idle is very simple. I'm just going to do this a few times. Sampling for 10 seconds.
You'll see this too, because eventually Rob's going to get a few of these, and then we're going to do some gestures like a chop and a wave. And the same thing you said before about the orientation of the accelerometer mattering, it's going to matter even more when you start trying to recognize gestures. So when we've done this in the past, we've sometimes like taped the accelerometer to something like a wand or to the note carrier to try to ensure we have a consistent orientation. it doesn't matter so much for this workshop. If your data is not perfect, it doesn't matter much. Like we're just playing around right now. But if you're, go.
I'm just saying, I'm bumping the accelerometer around a little bit in between these samples, so it doesn't have to be like perfectly aligned forward. And I'm just going to do one more here.
Because I'm just saying, if after this, you're going to spend your night making a robust data set, those are some sort of things to keep in mind if you really, really want to build a wand out of this that can detect different things, you have to put in some effort to build a really robust data set and consider all of those things.
The model is only as good as the data that went into it.
Yep.
And
it's to live by there.
If you wanted to use it in, let's say, like package tracking or asset tracking, just make sure that if you're putting it on a container, you do it in the right orientation when you're recording that container in transit, and consistently then, when you're putting it on other containers.
So I've just taken 7 idles. Now I'm going to do kind of the fun part here, which looks really ridiculous when we do this workshop in person. But I'm going to change my label now to, we'll call it up down. And I'm literally going to, and I know I can't really show this very easily. I'm going to take my accelerometer and just go like this, up and down. And again, keeping the orientation the same. And I'm going to start sampling. And oops, I'm literally going to be moving my accelerometer up and down from its spot on my desk. And this is especially where you want as many samples as possible. And you can see the visualization of that data, which is really cool to see as you're reading data from the device.
It is worth pausing a second though, because yes, you do need to capture a lot of data, but it's worth thinking about how magical all of this actually is, because you are building an ML model through this, which previous to me trying Edge Impulse, to me, I thought I'd need a PhD in mathematics to do, and I'm just able to do it in the browser, which is pretty empowering.
Yeah,
but it does mean we have to it does mean we have to watch Rob do this for 2 minutes. So, but we're still operating in the future here.
So in general, again, if you blur your eyes, you'll see the raw data visualization is pretty similar from sample to sample. Since I'm a human, I'm not doing every action exactly the same from sample to sample. But the more of these I gather, the better my model will perform.
Yeah, being that you are a human and there's slight variation, which we can see in that one, may in fact be a good thing for building a more robust model. It gives you a bit more data variety when the training is running.
All right, and do the last one that's going up and down.
It's worth also saying that we do perform this is where digital signal processing comes in as well, and we do some feature extraction, and we also introduce noise as well when training the model. So there is a certain degree of tolerance here that you wouldn't get necessarily if you built it yourself in your own locally, unless you factored that in. We have full dedicated team working on this.
So that was 7 samples of up down. I'm gonna attempt a circle. That's gonna be you do whatever gesture you want to do. I'm gonna do a circle, which is literally gonna be, I guess I'll stick with a counterclockwise motion here. We'll see how well this works.
Rob's so for the next 20 minutes, Rob's gonna build up a library of 22 gestures. Yeah. He's gonna
You're all good to stick around for another couple hours, right?
He's building a commercial. What's funny is my kids are big Harry Potter fans, and they have a toy wand that makes me think of this every time, because the wand can actually legitimately recognize different gestures.
I know which one that is. It's the Magic Caster.
Yeah. And it's really cool, but it always makes me think of this because it's it's an actual commercial project built with this sort of technique.
Yeah, I've looked at that and I've wondered if I can replicate it a little bit.
Yeah.
I'll stick that up on the same channel, but I've got a kind of a wand handle here as well that I
Mhm.
tried to use the last time.
Yeah.
Oh,
It's
nice.
it's a bit threatening looking, but it does fit the accelerometer.
Yep.
But I'll put it up on the same channel. But yeah, I haven't seen that commercial one though. I really want to see.
Yeah, it's incredible. Oh, and I'll find the link and I'll send it to you. It's
Yeah.
really neat.
So I've
Hey,
also got if you had the fortune of going to one of our in-person workshops when we ran this one, we actually did print some actual Thor style hammers. The idea being it locks the accelerometer into place and makes like a little more robust detection of this. But this is now this is going in my vintage collection on eBay. If anybody wants to check it out later, right?
That's one of a kind. It is neat though. It really truly is. I love
That's
that
nice.
thing.
All right, I'm officially getting tired of this. Let's see.
Do we have enough circles, Rob?
3. Yeah, that's 8. All right. So again, super limited, right? I've only got like 7 or 8 samples of each label, of each gesture type. Let's make sure I'm not forgetting anything here. That's what I did. Repeat it. Oh, testing. So this is another awesome feature of Edge Impulse Studio is that you can allocate samples to a test data set, which is really useful for after you build your model. So what I'm going to do is I'm just going to manually choose, I'll just say 1 for each. So 1 circle, 1 up, down, and 1 idle. And I'm going to move those to my test set. So using this move to test set button. And that gives me an 86-14 test split. I think best practice is probably 80-20 or 70-30, something like that. So that probably gives me enough to test my data set. And again, so what I did was I took those samples out of my training data set, meaning those test samples are not going to be used to train my data set. So we know that when we're actually testing it, we're testing against like fresh data effectively. Now I'm starting to lose my voice. So now we are going to go ahead and build and train the model. Here's where I'm just going to start clicking around, and Owen and David can provide some more context to what I'm actually doing. But the first thing I'm going to do is I'm going to hit create impulse from the menu here. And you can see that the default time series data, that's what I want to, that's the model I'm going to create here. And I think I leave everything.
Input axes are X, Y, Z. The window size is set to 1 second with 1 second increases. Yep.
I'm going to add a processing block, which is going to be the spectral analysis block. Again, my input axes are pre-selected there, X, Y, Z. I'm going to choose a processing block, which I believe.
We'll give you there's a
other learning block.
Yeah, learning. Yep.
It's going to be a classification, which I love. So even for an idiot like me, like that big star there, no. And the output features of circle, idle, and up, down. Those are the 3 labels that I created. I think I did this right. I'm going to hit save impulse.
Should be.
And
the labels were there. And we're talking accelerometer data. This should be good.
So now I'm going to head back to my menu and look at spectral features. And now I want to actually generate features based on my training data. So I'm going to click on generate features. Some more cloud magic from Edge Impulse.
Yeah.
When this is
done, this should only take a moment. The training may take longer, but this portion here should be really pretty quick. I
love the feature explorer that we're going to see here in a second. This 3D visualization of my data. I should see really clear pockets of samples.
Yeah, so we do have some auto tune.
Yeah, look at that.
So now I've got my my circle features here, my up, down, and my idle. So this tells me my model should work pretty well here. So where am I going here? Back to my menu, to the classifier menu option. I'm going to I don't know. Should I leave it at
How many is it on? I can't quite see. 30?
30 epochs. You could put it up to, I think, maybe 300, but
Yeah.
just for this, I think, yeah, 30 is fine. But if because an epoch it'll go through a full training cycle, so it could take a while if you put it up to 300.
Yeah, well, you know what? Let's try 30 and we'll see what happens.
Yeah.
If we need to increase it, we can always come back, but that might be enough. 30 iterations through might do the job.
So there's a couple of things that we do here in AutoML. So we have some auto tuning for the DSP. We also have AutoML where we fine tune the parameters at a later stage, and that's the Eon tuner. But those processes, they run through a lot of different configurations of the model and a lot of different parameter tweaking that you could do yourself as well. But they're kind of a longer process. They're something that you'd need to do before we have a break, let's say, but we might skip those right now. Yeah. And what it's doing here as well is it's getting to the quantization now, where it's doing it for a flow 32, and I think it's going to reduce that down then to the int 8 for microcontrollers.
And I think this is the last, so this is training the model. And then I believe after this, you get a model that we're able to then basically download for use in like the Swan or whatever other like microcontroller, more or less.
That is correct. This is the training, which is being done in the cloud. It takes well, I mean, it depends on the size of the data set and exactly what your parameters are, but it does take a few minutes, if not longer. I mean, I've had large data sets with, I think what's my largest personal one, I think is probably about 80,000 images. And if really running, a lot, like 1,000 epochs, it could take a few hours or more, but this was a relatively small data set with a few epochs. This take a couple of minutes. But yes, you are correct, TJ, in that the next step after this is you can do some testing. There are 2 methods for testing the model before actually deploying. One is the test data that was set aside. A second method of testing is using the web serial that you were showing off earlier. If you have your device hooked up to the computer, to the laptop or desktop, you can access it across web USB and, make the motion and try to see how well it performs. Oh, there you go. You got your training results. Got a model.
So I love this. So, and yeah, you guys can provide more color here, but in my data explorer, you'll see that there's a mix here in the idles that were identified as correct and incorrect. I often have that trouble with the idle classification. In this case, I think again, I don't know if it's too specific in the orientation. You can also switch between the quantized and the unoptimized model to see if there's one that's markedly better. In my case, the unoptimized one is considerably better.
Yep.
And since we're using the Swan, which has quite a bit of flash on it, it doesn't really matter which one you use.
Yeah.
I like
so
this too.
that's your next talking point, is right down there is the flash, the memory, the RAM and the ROM utilization for the model. That unoptimized is a larger one if your device that you are intending to use has the memory and storage.
So the inferencing time, if you can see, it went from 1 millisecond to 9. I mean, I personally wouldn't notice that, so I would stick to this. Right. And I believe the next step, as you mentioned, is to do the training. I'll show you one of the ways that you can, or sorry, not training, testing. One way to test your model is to use the test data. So you remember I set aside one sample of the circle, one up, down, and one idle. let's see what happens when I classify each one of those. And it'll automatically pop that into the window up above, or the tile up above here.
So it'll take the test data. That test data was not used in the creation of the model. The model has never seen this data before. It's completely new to it. See how it does.
And after this,
And I don't think.
oh,
Go Rob.
look at that, 100%, bam.
Oh, you crushed it.
So for
was
each,
able.
and I know there's a way, oh yeah, here it is. It's actually running, yeah, so it actually ran it 10 times, right? One for each second in the sample.
Yes, correct. Because you had a 1 second window, a 10-second sample. So yes.
Yeah, right. So if I've not forgotten anything. Oh, yeah. As Dave mentioned too, the other way to test is actually using the Web Serial API. So you can, I'll just show you where this is.
If the device is hooked up to the laptop, you can do a live one.
Yeah, I forget where that is. Oh, live classification.
Yes, live classification. Yeah.
So that's something we could do because I actually have the device hooked up, but I'm going to skip it for now to save us a little bit of time.
Yep.
Yada, 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 model testing. All right, we're on to the deployment step.
Deployment.
This is where it all comes together here. So if you click on the deployment option here, and what I'm going to do is I'm going to grab the Arduino library, and I'm going to choose the unoptimized model, and I can, oops, that is enabled by default, the Eon compiler. I love this, again, super simple option here.
So I can maybe just mention about the Eon compiler here as well, that it just removes all of the extra parts of the library that you don't need when you're running it on a device. And if you don't need to be able to interact with the device, so it just cuts out all of the extra bloat. So we've got up to 50% less memory used on the device then, which gives you more space to do things like build your rules and your logic on your Swan, or include your libraries. I know there's a lot of room on the Swan, but on other devices then that you may need to reserve some space can be used there.
Perfect. So yeah, the Arduino library is built, downloaded. I unzipped it as well. And now what I'm going to do is I'm actually going to literally just drag and drop this directory I downloaded onto the lib directory. And it's going to copy it in. So this includes the EdgeImpulse SDK as well for Arduino. And that's going to be, yeah, that's going to be all I need there. And now we get to the fun part of writing a sketch. And of course, we've already provided a full sketch here, so we can do our inferencing on the device now instead of in the cloud. I'm not going to walk through this whole sketch. You'll have to just trust the results here. But let's see if I can show off some of this. I'm going to blow away the old sketch I had and just paste in this new one. The one.
Well, we're going to find out if that sketch works right now.
I know. But I need to change the reference to my model, which I call it TinyML. Why did I use such a long name? With Rob inferencing. That looks about right.
I'm sure you didn't mess that up.
You know what? I'm gonna go for it here. I'm gonna do just a build just to make sure that.
And then when it fails, go do a copy paste.
Right. And the dramatic conclusion to our workshop here will be the output from the serial monitor.
And just to back up while Rob's setting this up, what we're hoping and expecting to see is the model. We were running it on EdgeImpulse's cloud infrastructure, but we're now deploying it down to the Swan so that the model is actually running on your Swan and pumping out the results into the serial monitor so that we can see it working there. And then underneath this too, Rob, if you want to scroll down a little bit, because we probably won't show this step, there's one additional step where you can also take the results from this and use the Notecard to send it up to a cloud dashboard as well. So this is kind of what David showed off during his Superman demo. If you wanted to take the results and pump it up through with the Notecard, that's kind of like the full picture that brings everything we've been talking about today through the Notecard, the Swan, Datacake, as well as Edge Impulse. So we probably won't cover that today just from time, but that is the next step if you want to head down to there and set all of that up as well.
Yeah, TJ's point is a good one, which is what you've done is, okay, you built the model, you're now pushing it onto the Swan. The inferencing is going to be done on the Swan.
You ready for this?
I'm ready.
So it's sampling, and it outputs the 99% that it's idle, which is great. And it's just going to keep looping through this. So it's going to keep doing sampling. It's still idle. Now I'm going to start doing a circle. And there, the prediction is circle. And I love it. It gives those percentages there. I'm actually going to do a circle the opposite way, a clockwise circle now. Still thinks it's a circle. That's all good, probably because I'm in the same like X, Y, D coordinates as well. I wasn't thinking about that. And then what was my other one? Up, down. Let's do up, down. Uh-oh, thinks it's idle. There we go. Up, down.
Do something chaotic so you can get some just completely random
I'll go
values.
like something crazy.
You're going to confuse the poor thing.
Not a number. You totally broke it.
Yeah.
All right. The dramatic conclusion. I'm glad to see it all generally worked. And yeah, we ended 5 minutes early. So thanks everyone for bearing with us for 4 hours. I mean, we covered a lot in that time. It flew by for me. Thank you to Owen and David for being here. Thanks to Zach for helping out on the support. And TJ, of course, for all your work. Thanks everyone for attending again. We'll send out an email with a link to all these resources we covered, all the tutorials. We'll get a recording up as well within the next few days. I'll trim it up to make sure we cut out some of the fat, but that's what we have for you today.
Rob, real quick.
Yeah.
I had a real good question pop in over on the Q&A. What are the best practices when you have to replace the model, basically software update? And that would give you a good talking point on, the outboard DFU and some, if, the one on my desk was a Raspberry Pi, so that's a little bit easier because you could always just stick everything into a Docker container and update the Docker container with a Docker pull. But over in the microcontroller world, you've got to have a think about how to reflash the device.
It's almost as if that question was planted because that's exactly
hey, did you pay him?
That's the exact topic we're going to cover at the end of August. So we're I think I mentioned it briefly at the beginning of the webinar, but we're going to host another webinar. I'm almost positive it's going to be August 31st. And we're going to cover like an optimized MLOps workflow, if you will, where we're going to demonstrate building a model with Edge Impulse, deploying it to the Swan. So basically what we did today. But the trick is we're going to deploy that device in the field in a more realistic production scenario. What's the problem at that point? Well, how do you go about updating that model with more real world data? Because, as we've said repeatedly, your model's only as good as the data you require. But once you deploy something in the field, you're literally getting arguably, the most accurate data, right? Because it's in the location, the physical location where you need to gather the data. So how do you go through an improvement process when something's deployed in the field and it only has access to low bandwidth cellular? We're going to show you how you can remotely gather data. You can send that data to Edge Impulse Studio, again, using the Notecard. And that's where that Edge Impulse route comes into play within NodeHub. How you can then build a new model in Edge Impulse Studio, download that model locally, build a new version of your firmware locally, but then actually deploy that firmware out to your device in a way that cannot brick the device. It's an amazing workflow. I think it's going to be totally awesome. No pressure. Anybody?
Yeah, I'm nervous. I'm not. You know what? I think I'm busy that day.
Yeah.
I just remembered. Got something going on.
So that's going to be super fun to do. So yeah, we'll make sure that everybody on the call is aware of that. But anyway, wow, 1 minute early. Look at that timing. So again, thanks everyone for attending. Have a great weekend.
Thanks.
All right. Bye, everybody. Thank you.
Thanks, everyone. Thanks for having us.